Double check your name, IC. And then kita positif dulu. Then later floor you receive digital copy of the service one. This is the evaluation form before the class finishes. We need to fill it out. later, the class will finish at 5.
Yeah.
Are you planning like want to go back early or something? No, right?
You see later how is the progress of today.
Okay. Because later I need to go to bank, need to settle a few things. I might be late. So normally at the end of the session I only used to take picture.
We take picture early.
Can. Let women come, then we take picture now, then we can just continue the training. Then later on, once all okay ready, confident ready, you want to end the session, you can end the session early, no issue. So we take the picture now. This to you. So, very good. Okay, just take it now. Yeah, I said again. So sorry, proof no, just close it.
Yes.
Normally when I normally edit your name and IC or ID really. Okay. Okay, thank you very much. Sorry for questioning. Just make sure keep in touch lah. Consultation is always free. So for all participants, so if you have any issue like troubleshooting or what, contact Mr. Kevin. Okay, please contact number.
Project.
One complete Siemens PLC
Oh, I think I see.
and change it to Brands.
PLC. blocks. Okay, add new blocks. Okay, then you put parts function. This one. Okay. So in the main, you call the FC. And you open the FC. Now what you do here, you put normally open I0.3 let's say is a sensor. Okay. Then let's say the sensor energize one output Q0.0. Let's say this is a motor. Then, so no need to latch, because this is a switch drive. Okay. So motor on, then you add here. Normally open motor. Okay. Then timer, EON. Timer 1. Just put 10 seconds. Okay, then you get the output here. I mean one memory. Then you can use the memory to off the motor. Here normally close. No, the motor off. Okay. So very simple. When the sensor on, motor run. Then when the motor run, timer start. After the timer, turn off. Right. Same like the one previously you do. Okay. You download and test. So why it's repeating? Because after the timer, right? This one will cut off, right? When this one cut off, motor will off, so timer will reset. So when reset, this motor normally goes back, right? So the sensor is always on the motor. Okay. So now we know the problem is the sensor. Okay? The sensor is always, but there's many ways to do this program lah, right? Even you can use the sensor here itself also can. Okay? But let's say the sensor is the one giving the signal, always the signal, right? So I don't want the signal. Here you go, right? I don't want the sensor to be always on. I just need like one pulse enough. Okay? But we cannot on off the sensor. Because sensor means, if for example I have a bottle, the sensor detect means it's detect. Okay? Because let's say the sensor detect, let's say let's say this is the sensor, then the motor is, let's say, the pump, okay, to fill in the water. Let's say I need 10 seconds to fill in the water. Okay? So the sensor detect, then start filling, then until here need to stop, right? So the sensor will be always on. Okay. So in this case, what we do, there's many ways to do it. One of the ways is make this into a pulse function. Okay? So you double click here. Now double click the register. Can you click it? Can you see? You have a P and N. P means it's a rising pulse, or you can name it like a positive pulse. So it means it's a rising pulse. Means the moment sensor on, I give the pulse. Okay? N means it's a falling pulse. Means the moment sensor on and off, then only I give the pulse. Okay? So when we want to on the motor, when the sensor is on, right? So we use the P. Yes. Okay. So when you use the P, so below here you need to give a memory then. Okay. So you can use the M0.1. Okay. So you can name it as a sensor pulse. So now this one become pulse, right? Means it's only give one signal only, yeah? So the motor cannot be always on. So need to latch the motor. So when this one become pulse, this one like become like a push button. This one pulse button. Okay. Now you download FS. Can? Yes. So you see, even though this one is true, right? Means still on, just give one pulse. So you off, you on again, and you give your same. So whenever you do something, then you see this is just an example. Then you see something, the input, I don't want the input to be always on. Okay, I want the input to on and off. Right. Then I can use this pulse function. Or the N negative pulse also can. N pulse means If the sensor is off, then only I want to on something. Then I use the hand mask. Now, go front. Now you create another block. Okay, timer. Timer function. Now click here. Okay. So we see the timers. Go to timer. You use the TP. You just put TP1. Okay. Here you put the first push button. I0. You put no. Right click rename. You can put any name now. Just put PB1. Yep. Just put 10 seconds. Then the output. Q0.1. Right? Lamp. Another one is for the second line we use the TON. Yeah. Okay. So this one, the input you use which input because I want to use a selector. So the first switch used already, right? You use the second switch. I0.4. This one lamp 3. Okay. Then you add another one, TOF. Switch 3. So TOF 1. Okay. Switch 3, lamp 4. one you put push button 2. Okay, and the R, timer R, right? Okay, and R you use the push button 3. Push button 3. Oh, this one is supposed to use 0.1, right? Have you used 0.1 already? Not yet, right? 0.0 here. 4, 5, 0.1 can you see?
This one use 0.1.
This one is 0.1. 0.1. Okay. PB2 correct. Okay, this one here you put 0.2. New. I mean delete. Yeah. Because both are same, right? So if you rewire here also change. So just delete this one. New one. I 0.2. Yes, PB3. Okay. So you see, if you want to learn some function, this is the way. You just add, just drag and put it here. So okay, they say here must one input, okay, boolean. Here also one input boolean, right? Okay. Then here is one value, okay. Then here is the output value. Then one output here. Then you just download and test. Okay. Right. What is it? Very simple. No, very simple. Normally when we open, we can see the green line, right? Okay. It means the PLC not scanning this FC. Yes. So the moment you can see there's no green color line, there's two possibilities. One is this one. Another one is the PLC is in spark mode. Okay. So just press the first button, first push button. See? Just give one pulse enough. The output will on for 10 seconds, then automatically off. That's all. Okay. So anywhere function, then we can use. Okay, instead of every time using this, right? Using this very straightforward. Then because for this I need to create for this I need to create two lines, right? One is to start the motor, then timer, then only cut off. Right? So this one is straight away. Unless let's say this is a push button, the lamp on for 10 seconds, automatically off. That's all. If the lamp is need to cut off immediately, means I want to put a stop button here, right? In that case, then I can use this. I need to see some other timers. Okay, you go down. So this one is normal timer, right? You just on the switch to on, you off, cut off. Yeah, like normalized one. Okay. Timer off delay. Go down. Switch 3. On. You see, when you on, because it's an off delay, right? So means when there is an input, the output will straight away on. Okay. You off the input. I will delay, then only I off. It's the opposite way of the on. On is I delay 10 seconds, then only I on the output. For off is I delay 10 seconds, then only I off the output. Okay. So this one TONR is the same thing like our TON. Okay. You on this push button, just press and hold. Okay. So you keep on counting, right? Okay, you take out. You see, stay. So once I reach my value, okay, you on again until so you on. So if the input is off also, the output will be still be on until I reset. TP3. So it depends on how you want. So you need to know all these functions you have, right? So sometimes whenever you program, suddenly we need something like this. Then we can, instead of using the TON only, we can use this just to simplify your program. So that's why there is a lot of functions here. Because all the functions are to simplify your programs. Without that also, some of the programming can run, but to simplify. That day I saw one, when I go troubleshoot, I see one machine program. Actually, in the HMI, you can create recipe. You know, recipe means, for example, let's say you have different type of waters, right? So it means the valve open and close will have a different timing, right? So for this one is like you said, like your system also got recipe, right? You need to keep all the recipes and everything. So actually in the HMI itself, there's a recipe function. So you can use the recipe function to key in, load everything. Then once you key it, then you just look. So which one you want to use, just click OK. Because all the value will go to the PLC. On that day when I go troubleshoot, what happened is he didn't use that HMI recipe function. He created his own program. So he created so many data registers. So every time you need to key in, you need to look for the value going. So big the program. So I mean that is PLC. So you can HMI already have the recipe function. You can use the recipe function. But if you are not familiar with the HMI recipe function, you can do your own in PLC. Just need to know, just need to understand how it works. So what is recipe and how it works? I also, when I'm troubleshooting, I also see why so many functions. Then I go to the HMI and see they use recipe. I thought they use recipe function. No, they just put the numbers on it. Number set, okay, all the value go in. And we program. Okay. So any question here?
For
No. For this right, I asked you to hold because there's no more switch. That's why. So it's the same like the TON. So when there's an input, start to count. When the input is off, it's become stay. You go up. In this TON, okay, you on the switch to count. You off the switch to see go back to zero again.
So this is the reset of format.
This one is like a reset automatic. When there's a no input, the timer value becomes zero. Okay, but go down. But this one is the push button is because we don't have an input anymore. That's all. So when there is an input, I start to count. When the input is off, I stop the counting, not reset. I stay there. Then again the input on, I will continue until I reset. Okay, good. Alright. Any question on this?
And then for TP, right?
Yes.
The throttle I on,
Hmm.
and it's not I release the push button, then it will stop.
No.
Count.
No. That the pulse is I just need one pulse enough. I always will count. Not like the TON. TON, I push timer run. I take out the timer reset, right? But here no. Here I push the output straight away on. Even I release this, the output will run. So this TP means at the input here, I just need one pulse enough. I will start my work. Even so, this one, if let's say it is continuously on, okay, you just press for 10 seconds. PB one, just press until reach the 10 second. So 10 second it will off. Even though the input is still on. So means are very simple. Every time here I receive a positive pulse, then my output will start, run, then off. Even I multiple time I press also it won't work. You press, okay. Again you press, nothing. So you finish the work. Next time you receive the pulse signal, then only it start to come. same thing. If you want to learn anything, right, go to instruction. So suddenly you see some functions, okay. So all is here, program control, and this lah. And then you see function, you just drag and put it here, or you can go to the TONR, bring the mouse here. Maybe just click there. Okay, wait, time accumulator. Okay, click on this. Yes. Go down. Go down, go down, go down. Go down. Here, like example, right? So this can put like this one example. And once you example, just you try to on. What is it? Try to on the input and observe what happened. Then you off the input. Then you see the timer stop, right? Then you on the input again. Okay, good. Yes. Okay. So now, do you want to go through your program or we do a project first?
The top function, right?
Yes.
Has one more
Negative first. No. You just change this to negative first. You can just try it. Okay. Download. Try it.
I got some function block yesterday. I review back the set reset and reset function.
Oh, the set, reset. Ah, okay.
And three got one R trick
Ah, okay.
and the link and TPR. The TPR is set as a TONR.
TPR.
Yeah.
Okay. Am I missing the bit?
Okay. The networking comes just like TOF on off then.
Something like that, yeah. But you don't compare with the timer. Timer is different lah. So this one is very simple. So the P means from if the signal lah. So it can be input, can be because this here right. It can be a input, can be a Q, can be a memory also, right? So very simple. If the signal from 0 become 1, so if I use P from 0 become 1, I give the pulse. The N is from 1 become 0, I give the pulse. That's what that is. So because it's just Boolean, right? So Boolean has value 0 and 1. So the moment it becomes 1, right? Is the moment it becomes 0, we call it as a, and so this one, so that's why they call as a rising edge, and this one called as a falling edge. Okay. So just now you said the what R trigger, right? Okay, R trigger. It's actually the same thing like the positive ones. is the rising trigger. You F in the beat. Here the one you can see here. Okay, good. Okay, maybe you can use here lah, but you need to use the memory lah. You can't use the inputs. That's the one. That's the problem. Okay, go to what do you use save as lah. Save as a lesson 2. Your laptop got license, right? Did you bring the laptop? Yes. Okay. Later we see license. Because in the same laptop we have 14 and 17, right? Good. Later I see. Is it one license or 2 license? If only one license, right? Then actually you can install 18. Only license. I can give you the installer, or you can download from Siemens also. But I reject it. Okay, we go offline. Yeah. Delete this one. Yes. Okay, this one also delete. Then go to, okay, of course, I still need to delete. Okay, then go to system logs, program resources. Yes, delete all this. Okay, save it. Okay, now go to main. Now click here. So now you want to want to see the set reset, right? The flip, they call flip flop lah. Okay. Go to big logic operation. This one, right? RSSR. Okay. You take the RS, put it here. Take the SR, put it here. What do you do? Both the same, right? Means here I set, here I reset. That's all. Correct. Here I set, here I reset. But what is the thing? S1 R1 is okay. In this case, S1 is the more priority. Okay. So if both on, right, the output will be on. Because the set is still on, right? So the output will be on. Here, the R1 is the more priority. It means if both on, it will always reset. Something like that. Okay, we do one. Okay. Here you put, because you want to use selector or, because one we need to use selector, then only we can understand. Okay. Maybe the one you can put PB1. We open. Then this one can put this. S1 can put switch 1. Maybe the sensor. Put the sensor. Then you rename to switch 1. No, sensor name. output no need here. Actually no need. You put it straight away, put it here. Here. Yes. Because that is the output. Then no, yes. So if you're using here, this one no need. Or unless here put a memory, then here put the output. Because both this and this actually will be the same thing. On at the same time, off at the same time. So it's up to you whether you want to use here or here. If I put it here, I don't need to put something here. If I want to use at the output, the Q, here I need to put something. Cannot leave it. Okay? Put down, same. This one, PV2 switch to. Download. Okay. Now what do you do? Okay, you on the S1. Okay. So it's the output is still on, right? Okay, you leave it on. Okay, now you on the reset. Push button one. Can you see? Cannot reset, right? Yeah, but you still keep on press. So the output still on, right? Okay. Do the same thing here. Now you on switch to reset, right? Now you on the PV2. Can you see? It's always reset. But if you off the switch to, of course lah, you can on. Okay, off the switch to. You press the PV2. Of course, you can set. Okay, then leave it. You can always set. Because you are using set reset, right? So it's always set. So it's normal. So this, if you off the switch one. So the moment I get the S, okay, I always set. The moment I get the R, I will reset. Same like the normal set reset function. But let's say if both on at the same time, what happens? So that's why they create like this. Okay. So if you want the set is more priority, because let's say if both on, I want the system to on. Means I use this. S1 is a priority. In this case, if both the sensor or both the signal is on, I want the system to off, or can be anything like can be output something, but I want to off, then off. Normally they use this in the alarm function. So it means this is your alarm, this is your reset button. Okay. Then here they put the alarm. What is the alarm? High temperature or low temperature, high pressure, all that, right? So they normally use this one, normally SR. Okay. So the moment the alarm on, I reset, press reset, then I give the priority for the reset. Okay. But the moment I take out, if the set is still on, so it will on again the alarm. So what happened in the HMI? Okay, they see the alarm. Okay, what they do, they press the reset button. I reset. So that suppose the alarm will off, even though the signal is still on, but in the HMI the alarm will go off, right? But the moment I take out my hand from the reset, if the alarm is on again, it means what the alarm is still there, so means I need to go and check the alarm. Okay, good. Any question here? That's that question. Go down. We see go offline. We see the R trigger. Go to the C. Okay, you can make it. Okay, you bring the mouse to the P. See here. Wait. Okay, scan for positive edge. Simple. Output Q is set to 1 and the signal state transmission from 0 to 1. This one. It's a pulse trigger. Like a pulse function. Okay. But the output is set. Okay. You go down. Next one is the AND trigger. It's the same thing. The output Q is set to at the signal from 1 to 0. Okay. So then the same thing for the R. Okay. So this one is a specified tag in the instant DB is set to 1 and the signal state transition from this one. Okay. Take this one. I'll trigger it, put it here. Okay. So it's a DB. Yeah. They must use a DB. Okay. Okay. Alright. So here is the input. Here is the output. This one. So input VBR trigger. You use you put the switch tree. Yes. And the output you put land. Okay. Okay. Down. Okay. Rising trigger off. On again. Okay. Go to instruction. Go to the R trigger again. Detect positive signal. You go to, because I want to see the output is a set or just pulse. for one cycle. So this one also is a pulse. That's why. So what you need to do, maybe you can close. Okay, you go offline. You click here. Add one line. Put normally open. Okay. You change this to a memory first. M0.0. No, you double click. Delete M0.0. M0.0 I haven't used, right? Okay. No, this is one from the previous one. Use the M0.0. Okay, then now you set one output. The set, you use the set. Set or pulse also, set or latch also can set. Okay, then because I need to reset, right? Okay. Go down. Okay, put it here. You put F. Yes. Same thing. Okay. You use the same switch tree here. Yeah, input same. Output use different one. M0.1. Okay, good. Reset. No, LAMP, yeah, reset, LAMP 3. Same thing. Download. Go down. Go up. It's to go up. Okay. You off. Okay. So you see, you on. So I receive the positive signal, right? Then I set. Right, but I can see this line on, correct? Okay, actually when I on, this one get the pulse signal I send to here. Okay, go down. You off. When I receive the falling signal, this one pulse, this one on. This actually, this one is exactly same like the P and N. But you see how it works. Okay, what is the difference between this? So you see, if P, okay, so this is the signal, correct or not? Then here it gives the pulse, right? So it means only one signal. Okay, here is the memory lah, so we don't care about this memory. So I detect this signal, then I give the pulse. Okay, and what is the R trigger is? That's why they call detect. Okay, this EN means is an enable lah. ENO is an enable up. Okay, don't have. This is the Q. Okay, this is the thing. Okay, so it's the same thing. Okay, this is the signal. This is the pulse. That's all. But here the pulse I can directly set or something lah, right? In this case, I need to take the pulse and I set. It means actually this one is exactly the same thing like this. Correct? It's the pulse. Only thing is I'm using here. Why? What is the difference between these two? Right? Is this one is scan for the difference from 0 to 1, right? Here scan the difference here. Okay, from 0 to 1. Here is it scan for the signal here. It means it can be like a logic. You want to create a logic also can. So means like a few functions that this one must be on. So for example, S1 on, S2 on, then only I on the pulse. So if I have more than 2 signals to detect, then only I can send the pulse, right? This one is only one signal. So that is the difference. Okay. There's another one, the P and N trigger. That one also same. Similar thing, but I think straight away set the value. We go offline. Go to instruction. The P trigger. Yes, we take the P trigger. Okay. So this one is same thing. Same like this one. No, it's the same like this one. Means it is the P trigger is here the click. Here is the output, right? But the output, if not mistaken, it is send the output. Okay, we try one, then only we can understand. Yep. Set the output. You see lamp 4, right? You use lamp 4. And in front of the P trigger is you add switch, any switch 3 also can. Use the switch 3. Then here below you must put a memory. This to check M0.2. Okay. What you do? You go to the P trigger, then you go to the help. I was for a very long time to use that. You state the output Q is set to 1. Okay, current H memory bit and of the previous phase, result of the HMI should go down. Okay, wait, the earlier previously just a pulse only. Result. Okay, so I need to set also. Close. So we put a set. Yes. I don't need to reset. Later is okay. So download. Monitor. Switch you on. Yes. So this one you didn't give the signal, right? But already set. Go offline. Set. Yes. So this is actually same thing like the pulse also. But why they do like this? Because okay. So means here is the signal and here is the here I give the pulse lah, right? So this one you see a difference here because here the straight away at the line it give the pulse, so I can straight away set something. But here just give the output as a pulse, so I need to use that to set. Okay, so here also same. Why? Because it can detect like multiple signals. So like multiple signals. Same like this. One difference is this one detect the signal, send the pulse function to the queue. Then you can use the queue anywhere you want. This one is detect the pulse, right? Positive, negative pulse. Okay. Then it will send the signal to the queue where you can give some directly some output there. That's the difference. So normally this one they call, that's why they have a RLO, right? Okay. RLO means it's like this, they indicate this line, this detect. Okay, okay. Okay. Other functions, what the other functions they have?
I see for the TOFR. Same our
Oh,
TOFR.
includes this.
Yeah.
But here don't have.
Here don't have.
Don't have. Hmm. That's why it's good. Yes. Hmm.
But the concept is same, right? In Siemens and policies, the writing program.
Yeah, it's similar because they're using the IEC. Because what is this called? This one they call IEC. They have a standard in programming language they use. But this one you're using function block.
Yeah.
Hmm.
I early on they teach me
Function block.
Yeah.
Hmm.
and more
Familiar with the function blocks already.
And
Yes, sir.
others I think is more so much function
Hmm.
they use almost the same
Same thing. Hmm. Function block, yes. They do the program, yes. Yeah.
Combine like this. So, so I don't know where to start to see.
How to see the program?
Yeah, sometimes it's here for a few
All function.
in front or at the back.
Okay. Actually, this one similar to this also. Is it for HDMI, right?
Yeah, got
You can connect HDMI. I can show you. This is the same thing only. You just need to understand how it works and can.
If the block is more easy, then I can understand.
Yeah, of course. Because now only you starting, right? So
Yeah.
that, of course. Another thing is always if you want to understand other people's program, right? It's always difficult.
Yeah.
Always difficult, I know. Because that's why whenever I go for troubleshooting, I don't try to understand other people's program. So what I do, I just focus on okay, what is the problem. I say there's one valve cannot open. I just focus on the valve. I just check. I just do the cross reference, reverse engineering. Okay. So why the valve cannot open? Only that only. You cannot understand.
Because sometimes the final testing engineer he will ask me how this, for example, how this valve will run or what time he will reset. So I need to go through the function log and I need to
Tell him lah.
Yeah.
Oh.
So sometimes I also need to how to read this function log.
Okay, good. Alright. Okay. Because it's similar like Omron. It's similar like Siemens lah. Okay. So. Okay. This one, right? Okay. For example, this one. So first we need to understand how the TOF work, right? Okay. So TOF is when the input on, the output straight away on. When the input off, the output will off. Okay. So this is the AND function. AND function means, so I have 3 lines, all the 3 must be 1. Right? 3 or 5. This one is good. This one is right. Okay, so total I have 5. So 5 signal, all the 5 signal is on, then the output is a single mode condition. Okay. Now we see one by one. Okay, the first signal is from the OR function. So either one is on, I straight away on already. Okay? Okay. So then here also same. If either one on, okay, I give the signal, either one on, I give the signal, and these two must be on. Then only the output will be on. So this one also same, like RS, right? Reset, set. I mean set, reset. So can you see reset is 1, right? So reset has the more priority. Okay. So it will set this and also this got 2 lah. Because this one also it will set, this one also set. Okay. But I think in this case, in the code disease, I think it will set because shift on size. I think they set this one. This one they just put like a memory.
Yeah, because I can rename it.
You can read, I don't know. You can rename it, I know. So this one is like a memory because the output they're using here. Like just now for the Siemens, the output on top, just put on here, right? So for this, they use this. Okay. So this one is a compare function. Compare is it greater than? So all are right. All function. This one less than. So if this position, I don't know what is the ill pin position greater than 25, then one of this is on, I reset. Okay, then this one is less than. If this one is less than this, I set. So very simple. This is this signal twin nominal position. So if it is less than 25, I on this signal. If more than 25, I off the signal. Or if this one is in single mode, I off the signal. Two condition. Actually, this one, actually you learn in function block. Actually, is good. You know why? Function block and ladder compared to. If you compare both, ladder is easy to understand. So you already learned the tough one. So ladder is easier. So you can just go need to understand all these functions, all this. Okay, go down.
Yeah, sometimes like this the front or the front.
Yeah. So if like this, so of course like this one cannot convert to. You right click here. Can I change to? Project database object team. Cannot. Because they already choose, you know, in function block, right? Here I think they're using SCL, I think. No, SFC. Yeah. This is the SFC program. Sequential function chart. All this in one program, is it?
Yeah.
Okay, go to main. So in the main just call lah.
Yeah.
Call. They use one function here. Okay. Go up. Okay. Very big program.
Yes. But here the program is the fixed size, so I only change is the canvas size.
The canvas. What do you change there?
Normally I will check with the drawing, the I/O, and so this will change according to the drawing. So I need to compare with the drawing and I change one by one. And this one is from the HMI, so I also need to
Convert the data lah.
yeah.
Because why got so many? Because of what?
Because this need to communicate with the HMI, so the HMI then will also have the TX and RS.
Oh.
Yeah. The HMI, I got over this one. I just simply over one. This one,
So also using the code disease.
yeah. This one is for master, and this one sometimes using in master also, but sometimes HMI only.
Oh. Yeah.
So my problem is I don't know how to understand well each the function block.
Yeah, of course, that's the thing. So is okay, this function block, of course, there's a program inside, right?
Yeah,
Okay.
the program design. But if this small I can
Yeah, I can understand. I know.
But sometimes I got complicated one.
Just now, like just now.
Maybe like this maybe got one more.
Oh,
yeah,
this one.
yeah, this
Sure, this one can.
this one I also not sure where to start.
Okay, always start from the output.
Yeah.
So, what happened is, but this one, if you want to troubleshoot, right, that's the problem. You know why? Because you are not online. Your engineer will online, right?
I will go to on
Or you can go online. Okay. So when you go online, the best way is you go online. Let's say there's something, this one is not working, for example. Then you go online and you monitor here. From here, then only you can get the data because it can show you the values, right? 1 or 0, right? Okay. So from here, because this one is TOF. R means it's the manually reset. It's the same thing. TOF means when the input on, output also on. Okay. When the input off, output is off. Okay. Again, the input need to on, right? So I need to reset the function first. Or what you need to do is, if you want to understand better, you create, because this one can do simulation, right? So you can create one TOF, try to understand first how it works. Okay. So the reset we take out. Reset means it's manually reset. Okay. That's all. Okay. Then okay, this one got help. Go to help. Go to content. Not search. Wait a minute. I think search also can. If I'm mistaken. You just put TOF up. This is the one I tell you, right? IEC standard. Something like international something. Okay. So that's why it's the same thing like in Siemens. Because Siemens also they follow, especially the TIA portal, not the older one. The SIMATIC manager they don't have this standard. They follow this. They have some function. They follow this. Some function not. So that's why they use. Okay. Okay. Open. You have. Okay, we go up because okay, they have everything in different. So this one is in instruction list. This is in FBD function block diagram. Okay, go down. Go down. This is instruction text. Go down. But why there is no TOFR? Right. Okay, go to index. Just put TOF. Okay. TOF. Okay, go down. Go to content. Programming system. IEC operators, arithmetic, comparison, type numbering, initialization, operands, variable, data types. Keep also data types. Put on. Code disease library. It's the time. around here like go up. E, E, and I. So E and I. No. Arithmetic is like a calculation. You just plus. Okay, calculation. Okay, off. Then big string operators. Okay, this is the and not okay. This one all shift. Okay. Selection. Okay. Comparison. Okay, so it's a comparison. Calling type conversion numeric. This one is a boolean to both the same thing. Maybe you click here, TOF, then you click F1. F1. Okay, right. Okay. So we just go to here. Sometimes we click here, it will open up the TOF. Must be online. So this R trigger, this one also you need to test manually actually. You know why? Because here this R trigger, the Q here is a pulse only, just like one pulse, right? So you need to manually create one program to check whether the R trigger is it a pulse or can be that on. But if you ask me, it should be the same thing lah. But if you see here, because if it is said this is a pulse, right? Means this one is this signal also will be the pulse signal. You know why? Because this is a AND signal, right? Got 3 data, right? Okay. So let's say this one is already on, this one is already on, right? Here I will get only one pulse. Means this signal also will be the pulse. Okay. If this one I want to do in ladder, can, but big lah, maybe bigger. So this signal also is a pulse signal. You see, because this one is also pulse, right? I mean this line, not this line, huh? This line. So this line is a pulse signal. So this one should be the always on line, right? So if this one of this is on, okay, on, then I have a PT, a timer. After that, there is this output, and if all this on ready, then only here. Is it this one is an invert?
Yeah.
Okay.
So which means the pulse go here and until this one input.
No, it's just like one pulse only. Like one signal only here. After that off.
Also the input give the command, then this one
Pulse, yeah, just pulse.
then I want to start next pulse, so need to give one more.
Yes, one more, then only can pulse. But the best way is to create your own program, one program, right? One sample program lah. Because you can the same thing you can click, you can put so many files, but right? Then this one is just creating the name only, right? So no need the what? Need to check the I/O, everything. Then when you simulate, it's easy to on the what? Easy to make it 1 0, right? So just create one, okay? So you just create for you. One, you create a timer. All the timer you put in there. Then one is the trigger functions. Then one is the what else? The other functions are also many functions, right? So whatever function is here, you create on your own program. Okay, understand that first. Okay, once you understand, then it's easy to troubleshoot this. But of course, this one if you ask me also, for me also it will be difficult. Yes, because you know I got so many interlocks. These are all interlocks actually. Because if I want to write down this one, I try to write down. But if I want to write down this in ladder, I need to start from the output. Want to start from the input, very difficult. I see better can do There's a TOF, right? So TOF, of course, going to be a TOF. So the output is what? Go to 30. So just put GT 30 line. Okay. Then this is the Q. So the ET nothing, the PT 1 second. Then this is the in R. Okay, reset what we have. Okay. So at the reset, let's reset the data view. Because this is easier to do in this way. Okay. Then here I have an OR function, the OR function, right? So it must be okay. And start from first OR function. Let's say OR function. Okay. Then N, which is not, I have two, right? So this is the W flash something, and this is the B03, right? Then one is normally closed, one is normally open, right? The defeat and the present. Okay. Defeat and present. Okay. Then it's an OR function with these two, right? So it means these two only empty here. Okay, then this is off. This is the output from here. And this one is the off, is and off. Okay, so it means so I have another one. This one is 4045 something. B04 N not N. So this is the 40 feet, 30 feet, and this is the present something. Then okay. So now this is all function ready. These two all. That is this, right? So this two is here, this one is here, this is all function, means this signal or this signal. Okay. Now N. The N is I have one N, which is inward, so it will be normally close. B01. One signal and ready means this is either one and not this. Then there's another one is the trigger, right? The pulse. Okay. So EQ, continue. Okay, then the OR function will. So this and this, then again OR function. Oh, which are very big. So you see how big is the code. You know why they do that? It's because make easier. If no, I can create this one. You know how? Maybe until here. Okay, until here, what I do, I create one memory. So where is it? Until here, right? Until here, okay, one memory. So from this one, okay, I create a memory, another line. Trigger, okay, this is the input. Here I put another, let's say M1, M2, another one ready. Okay. Then, so means this one one this one one signal, this one one signal. This is the M. Then go to the OR signal. So for this I create another memory. For this I create another memory. So if I'm using ladder, it's very big. I mean, I need to use multiple lines. If you ask me, if I do this one, I will do this one at one ladder. Then I take the output. This one ladder. Then this one ladder. I take the output. This one ladder. I take the output. Then for this another ladder. So total we have 1, 2, 3, 4. Four ladder. For each one, I take all the output in the memory. Then lastly, I do this. Using ladder logic. But this one, troubleshoot will be difficult. This one must be online. Then only you can know. Because then only you can know from where is the signal. So normally, what is the problem you face? For example, we try to see.
For example, maybe
This one, what machine you see? What system you see? This one?
what system? What?
I mean,
What do you
this is a machine. What machine is this?
We use the effect PLC.
No, this is controlling what?
Controlling spreader.
Spreader.
I'm using for one time that I show to you. I think how easy.
Then 1 until 6. Yes, correct. Spreader for a container, is it?
Yeah.
Okay. Oh, okay. So means your company is supplying this system.
Yeah. So from A to Z, we do from welding, grinding, then we will be assembling,
Oh.
then final testing. Yeah. So we ship the container.
Container lah. That one. Now okay. single lift, okay.
And this is the twin means can up the container two even at the same time.
So 2 containers.
Yeah, this is only for one.
So 2 container means one here, one here.
Yeah, so this is the fixed. So and this is the container then can shift to 45 feet or 20 feet.
Oh, this you mean this
Yeah,
body?
If this cannot, it only can fix
Two lah.
Yeah.
2 lah. Okay. So this 2 is which what is the size?
Size. So you can choose what size.
Oh, what size to? I mean this one is what size to? So,
Yeah.
but this one can be.
Can be you
So-
after you lift out, right? So you can open until 45,
Okay.
and you can also back to 40.
40 or 50?
40 feet. The 20 is only for single only.
Oh, okay.
Because this cannot be go back to
Too small lah. So it's 45 to 40 lah.
Yeah,
Okay.
it's like that.
So the program
Mm.
is controlling only these, or is going up, down, everything?
No, we will open the open the telescope
Okay.
and twist lock unlock.
Okay.
And sometimes we have the flipper up and down because we want to fix the container size.
Okay.
And some more we have hip block
Okay.
to connect with the test board.
Hmm.
And the test board also connect to the plan panel.
Yeah.
So we are doing this
Oh, okay.
and some more the spreader got wheels and the hydraulic pump.
Yeah.
And frequency drives, something like that. So we need to progress to each project.
Yeah, of course. So each project you, I mean, of course, like you will take the whole program then modify, right?
Yeah.
Okay. Hmm. Okay, so now you see what is the problem. Not a problem. If you ask me lah, what the problem is? The what? The models they use. I mean the controller they use, which is. It's not, if you ask me, for example, using Siemens like this, right? Okay. So if you are using Siemens drive, so you only need to do the configuration. Then you can do it. So you don't need to do the CAN bus, the communication on. So that's the thing. Okay. So where you use the Siemens PLC
Siemens only do with the crank panel.
with the crane.
Yeah.
So it's control the crane lah.
Yeah.
Oh, okay. So Siemens controlling the crane, and your what the impact controlling the spreader.
Yeah, it's for the operator to using a HMI to control and at the land.
So at the land, the operator will use the opus
Opus or impact.
or opus or impact lah, HMI lah.
Yeah.
So you can control that.
Yeah.
Then so the controlling the spreader, this one is using the impact
Yeah.
PLC. Then the crane is using Siemens.
Yeah. So they will communicate to share the data.
Yeah, of course, because the spreader need to send the signal. Okay, I've already locked everything. Okay, all the sensors need to send the signal to the PLC.
Yeah.
Then only the PLC can go lift or right. Okay. So the PLC there using this 1002 or the 300 also lah.
This one. I joined mostly using this one.
Using this one.
But our lab also got that one.
So the lift also got this one, right? The drive, right? The frequency drives.
Some spreader have, but some spreader don't.
I mean the lifting.
For lifting I'm not sure.
Oh, okay. Because can use hydraulic also can. But even the hydraulic, they will use a pump to rotate the motor.
Yes.
Okay. So this from the impact to the your PLC, you are using the CAN bus communication,
Yes.
which is I saw just now. Go to the program. Which is this one, is it?
This one, yeah, this one is to the crane, if not wrong, yeah.
This one is to the crane. So to the crane means it's a PLC lah. No.
To the crane will communicate with this.
I mean PLC to the Siemens lah. Okay.
So for this, we have one interface laser to match with each other. So basically this will not be changed. This will be fixed, or the customer want to add on some command or some status.
Then only you need to
Yeah.
add. Okay. So what you send here, this is the receipt, right?
Yeah, we see.
I don't think that. Go down. Byte 4, byte 3. Oh, okay. 3, 4. Okay, because you are sending booleans, right? You are sending booleans, but you cannot send one by one, right? So that's why they're using the byte lah, byte to boolean.
But here can also we send the fault.
Fault.
Yeah, fault also can. Fault is
Because this one is from the
from the
spreader to the crane, right?
yeah.
Okay. So the most important actually this not this one,
Yeah.
This is the one. So they create. Okay, you know what is this means? They create a array. Array means like a set of data lah. So bytes. So how many bytes are you going to go down all the way down? This is the last one, is it?
Yeah.
So from 0 to
It's from 1 to 8.
1, starting from 1. Okay. So from 1 to 8 means okay lah. 8 bytes lah. So they set of 8 array to send them. So this one is just moving the data. This is not doing the communication settings. So where they do settings, okay. Close this. Close this. Okay, you click here. This one is controlling. Okay, you go to control. Note card. You understand about this. Then go to here. This one only. This one for HMI, right?
Yeah.
All using the canvas, is it?
Yes.
Okay. Can 1, can 2 intake. Okay. Close this. Can 4. Okay, can 3. Can control. Go here. Master. Go to PC. This one is?
This one is for because we have more than one ECU, so this one is for master input and output, so we can modify here.
Okay.
So if we have ECU 2 mostly it will be select only.
Okay. So this is the spreader program. This is the program of. Go to me. this one is spread application. Go to this is you go to resources. No. Because all these are libraries. Data types. Do you have the Siemens for the program? Okay, this is the one, the same thing lah, they doing from here to there, right?
Yeah.
Okay. See, this one only. What I want is ticket. That's it then. Okay. So can control mean this is how they communicate. The what? This one, S7. This one, not cutting. So local CMM. Okay, go to device and networks. Yeah. Okay, just enable. So it's connected to this module, right? Go to device and device configuration. So the communication is connected to this module, right? Right, from the impact to this, using this module.
Yeah.
Okay. So this one, CM can open off. So we use the communication. No. You click here, property. So they put it here, all the settings, the can open settings. Click here. Okay, the body parameter is the baud rate is 125 kbps. Okay, mode number, operating mode, transparent. So they add the communication modules here. Can open this. I think you see that inside this quadrant, you can open. I mean, in TI portal editing. Inside TI portal editing, I think it can open into install separately. Go to device configuration. Go to communication module. Yes, it can open the left, right?
Yeah.
So need to install separately. Then only, so what they do? I mean, because I try to understand the communications. So what they do? This is your impact line. Then this is your S7-1200, right? Okay. So they're using the serial communication, right? Okay. Serial communication. So of course, they add one module here. So they use they call CAN bus communication. Okay. So inside here they need to add the module. So this one can install from the website. Can open function. Okay. Okay, you go to here. HMI. You see how to add the can opener. You disconnect the internet. Okay. Then go to Microsoft Edge. Put TI order. No, go to Google first. Type Google. Okay, TI order. Can open here. Can open. Just together. Can open. Yes. Module. Module GST. D. Yes. Denmark. Yes. Okay. Yes. So when I go up. Okay. So you see, to integrate the can open module, you need the GST file. Okay. Where to find this GST file? And ticket. Where to find download GST? Ticket. Modules plus you connect up to state nodes. Okay, go down. XML. You click it. Okay, download. Suitable. Right. S7-1200 can open This one the can open, you have 3 cable, right? Yeah. inside the folder. Right click, unzip to HSV. Fourth one. Okay. Yes. Okay. Now go to TIA portal. This one I think will be helpful for you because you know why? Because normally these are the this is not like a Siemens communication, right? Okay, Siemens communication is a Profit bus or Profinet. So this is like a third party communication. So when third party communication is involved, so you need to add that particular communications here. Okay, so go to tools. Sorry, option, support packages. Go up, go down, go down some more, go down, go to components. Go to installation. Yeah, installation. You see what is the need to add this file, HSP version 18 now. Go to add from file. Go to your desk. Yeah. Yes, open. Okay, this one. Click open. Okay, this is the one. So this is the one just now you see in the file, right? So need to install this. Click here, install. So once you install, then only I can finish. Okay, close. Okay, go back to the device configuration. Okay. So now I need to see which one I'm using. Click here. 010217 this one. You click here, just click on one thing. Go down here. This is the communication module with the chemical master scale transparent interface. This one. Best communication. It's the same thing, but I think this one more to what they call the rugged one, like more what durable one. You click this one. Bahru Training. Then note now. So this one is depend on what is your setting lah, right? Okay, now I go to main. What is the better? Now the basic can be off. Go to communication. Others. Focus communication process. S7 communication. Go to optional package. Okay, for that also need to install the one because in your file there's one function like for the communication. Need to install that also. So then only I can do the setting here. Because here I need to do very simple concept lah. From this to the impact, right? I need to tell, okay, this is the device. I mean, this I'm using this communication, and this is the address. This two is the most important. Then, how many data I want to send? HMI we do, right? Okay, when we do HMI, we put it there. Okay, this is the PLC. This is the communication, everything like the same concept. Okay. I think need to here also need. You see what is the in your PLC program? There's one function block you use, right? Now I see one function block. Your PLC. Now okay. Control name. We go to communication. The others one can go to the top one. Yes. Here we can go to others. Open user communication. Others. Communication processor. Pull out. Point to point. Again, what is the FC name?
Can control.
Control. They create their own blocks. They create their own blocks. Then maybe they use this one. You go to optional page. because when we add the module, right, the canvas, so it's a 9-pin module. The 9-pin module we call is a point-to-point interface. So they create their own blocks because you know what? Is these special blocks, right? These are the special blocks. Right? Special blocks. Once you choose here, it won't come here, you know, and it won't pop up here. Means just now we see the FC7, right? Means it's not a special block. They create the block. That's why they locked. Okay. So they use these functions. That is, this is the port configuration. Then this one I think is a signal. You bring the mouse here. Query signal. The instruction query is current state. From this one go up. Send PTP. Transmit send buffer data. Yes. Communication module is CM, right? So send point to point. So this is transfer data from the send buffer to point to point. Means you just take and put. Just add here. We see what data is. Display okay. So the port number just now when we went not 1. Correct. Port number is not 1. Then buffer is how many data you want to send. They do something here, but what they do, they didn't do in main only. They create in another FC. Then they all this they put some internal tagging. Then they lock the FC, so the others cannot, you know, see the can crack. But you know, expensive. There's a guy on the internet. He sell all this software to crack this function blocks. They lock the block, right, and blocks out. But very expensive. I think to crack one block only, $30, $30-40. One block. That one also, he won't give you the software. Okay, you need to send in the TM file. He will crack and he will release the password and send you back. He won't tell you what is the password. Okay, close this. Okay. Because all these are, you need to add the device, then only you can test. If no, we just do like this, we don't understand, cannot understand. Need to add the device. Okay. So any question until here?
Can I show one more?
Can.
Can I want to ask?
Sure.
This one, I want to ask, because this program we are writing for, we start run for the endurance test.
Okay.
So my question is, this function block is for the spreader to do their sequence telescopic movement.
Okay.
So I want to know how to know the sequence according to this function block.
Oh.
Because if I see my serial expect to me the sequence of it will be this one first and jump to this or jump to this and then jump back to the first like that. So I want to
Okay.
understand.
Okay, now the problem is, the first thing is I need to understand the names. Okay, now when we go up first. So means this is the sequencer, is it?
Yeah,
Now, so this is the program, is it?
yeah,
Okay. So this is not related to others,
still related.
Still related.
Yeah. Because the endurance task is
So this one is so this program is just to check to do the endurance test.
Yeah, to let the spreader keep running,
Keep running
8 hours.
8 hours.
Yeah. So it will not stop unless we press the stop button.
Okay. Where you see the hour?
Hour.
The 8 hours, right?
Oh, they only let they run until, for example, they run from start from 8 a.m. Then they will stop at 6 p.m. like that only.
Oh, so there's
Manually count.
manually lah. Oh, so means they don't have like in the HMI it won't show how many hours it's running.
Because it is for internal testing.
For your own testing lah.
Yeah.
Okay. So no bad. Okay. Okay, good. Normally if you ask me, okay, normally the program will be of course lah from here to go down lah, right?
Yeah.
Okay. So this one is what the command bypass landed.
This one is for the start. Before we start the endurance test, so we have to make sure this is all fulfill the condition, then it will be start.
Initial. Okay, ini the test lah. So set. So of course this one is resetting. So and so means is a landed delay must be on.
Yeah. Then the spreader must be
Stop. Okay, it's in stop mode, right?
Yeah.
It's in stop. Okay, then the bypass landed.
The center is only they will render the spreader.
Okay. Then it will set the system. So when this one set, okay, I wait for 5 seconds. 5 seconds, then I just get one pulse, TP, then this one will on, right? TP means just pulse lah, this one. I just get one pulse only, this one on for 3 seconds, that's all. Okay? Then go down. So where I use this?
This one will be here.
Here. Okay, go up. So this one is the CPU cycle e-test counter.
Yeah.
Okay. So if the test value is 0, so someone reset lah, right? Reset is 0, okay, then it means start lah, right? So every time one of this is on, I will count 1 lah, because they put all function, right?
Yeah.
Means if 45 feet done, okay, I 1. 40 feet, 20, so every time one signal lah, one. So extend, retract, single, twin, okay? So every time one signal, I just count lah how many. Okay, go down. So we can start. Then if it is position 20, position 45. This one is what? SR.
SR is here.
No, SR40O. Q1, oh, this one, the output here. If okay, this one means if this one is not on lah, means because they put not, right? It's the invert, right? So it means, so we don't care about this. So if this one is in and this one is in, so if either one or function, then the start is on, the GT is on, put 5 second delay, then from up there the test is on, must be in single mode, and at correct position. This one is must be off lah, right? Because it's an invert. Then only I reset this. Then SR40 go down. Go down. This one is the same thing, but this one is 40 and 20 feet. Just now is 40 and 45 feet. Okay, go down. Go down. Test. That's all, is it? Reset, then I reset the counter. What? 15, right? Okay, never mind. Go for your break. After the break, you come and see. Because here they put the steps, right? So we can follow these and see how they work. Because this name one, I think you really can understand. This name.
I cannot understand start from the sequence. How
So,
we will start.
how they starting, right?
Here for the telescope movement.
Oh, which one is telescope? This is telescope movement.
Yeah.
Oh, TL means is telescope lah.
Yeah.
Okay. So telescope X on means is it not on?
On position 20 feet.
X in front is nothing.
It is only declare on here.
Oh.
Because if I show here, will only like this only lah. So all the X are all got X.
Okay.
And here's one. Here also X.
Okay, I think they put X, I think maybe, not mistake, I'm not sure. Maybe they indicate that is what? It's a boolean maybe. So telescope on position 20 feet.
Yeah.
Means it's at 20 feet.
Yeah, it can.
It's
It
open
can open.
and
It can extend and retract.
so 20 means it's retract lah
Yeah.
at this position. 40 means it's this position lah.
Yeah.
Or 45 lah, right? Okay. So any position lah. So any position is starting, then it's already started. Then GDT 20 feet. What is GDT? Where is it from?
This on command during 20 feet. So you will ask to go to 20 feet. Except this one is N.
Okay, so this is a command, is it? From where? This command.
This
Mm.
command.
It's a variable global, right?
Yeah. Also variable.
Yeah.
For this on this is space. All the DT variable is special for this and endurance test only.
Oh, okay. So is it input? Is it a HMI input or is it? So it's just like a memory.
Something like that.
Oh. Okay. Just from your keyboard, the first one.
From here.
No, I want to see from where is it from? Your progress. Test. This is the out. Okay, next. 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 Oh no, I want to see where, right? Okay. Where is it? So if this position is okay, then I write means I make it this one on lah, right? Make it on. After 5 seconds, I on this. Then I use that to do the counter. Okay. And we go for your break. And after the break, come and see how to see this one. Maybe I need to list okay from here to here like that. Then you can understand. Okay. So this is just the output, like the coil. one signal going to set the RS20. Another one is the on this what? Yes, 20 feet. Then I use this 20 feet here, and if I press the reset, then because ends and end, right, I will reset this way.
If not, it will be continuous running.
If not, the RS20 will be still on lah. So later we need to see RS20 where they use. Later we do I think we need to use the cross reference. Because that's where we can find out where I write. Normally that is what I do. I find out where I write. Because read are not important.
Right is
Like an output.
the real output they ask to do. Is it?
Yeah, okay, where I on this particular memory. Because I need to know. Because the read all means is someone is using back this one. Okay. This one they are using, right?
Yeah.
They are using this bit, correct?
Yeah.
Then just now here also they are using the bit. But someone need to on the particular bit only. Like a relay, right? So these are the relay contact. So now I need to know who on the relay. Then only we can find out. So now who on this one? Okay, from the timer. Why the timer on? Because it is press start and it is a GT. This one must be in on state. When you test something, right? On state, and it's the OR function. So if one of this is on, I reset the move, right? So it's like an output, like a coil. So we need to find out who on this. Then only we can know why the GT with the 20 feet on GT 20 feet. This is the output, right? See, I compare the counter value and your telescope at the correct position. TW is what?
Twist lock.
Twist lock. Okay. Twist lock is all unlocked. I wait for 3 seconds, and this is the twist lock unlocked, or the twin is locked, and this is the last one. So this is your output. So the thing is, you need to know why the output. So from there only we can find out the sequence. Okay. So means when this one is the first sequence. So first one normally be like a ready sequence. Then only go to the next one. Go for the break and how it works. Okay, first, you close this. Cross reference here. Close. Go down here. Go down. Okay, ready for step 5. What is step 5?
Step 5 is also go from single in change into twin.
Okay.
This means single only can live out one.
Yeah.
Twin can live out two. So you will be ready and the twin will twin down.
Oh,
You will be at standby mode.
standby mode lah.
Yeah.
Okay. Right. Go up. Go all the way up. Okay. So this one is the CMLP is what?
Landing.
Landing pin.
Yeah.
Okay. Then general is general.
Yeah.
Okay. So the landing pin and the lander delay, okay, all okay. Then I set this, right?
Yeah.
Okay. If I set, then after 5 seconds, I on a timer and also I will on a so it's got DT on. DT is what?
This is the during and during test.
Oh, so means
Declaration.
oh okay. So means DT means the during and during test lah.
Yeah. Then it will on the system. On the process.
Okay. Okay. So means when the landing pin is bypass and lander is okay, then I set DT to on lah, right?
Yeah.
Okay. So means I on the test lah, right? I enable the test, okay? Then after 5 seconds, I will on the DT on. This one.
Yeah.
This memory lah, okay? Then after 3 seconds, no. In these two, okay, this one on, at the same time this one also on. Both will on. Okay? But this one will on for 3 seconds. Right, because it's a pulse, right? TP. This one will on for 3 seconds, after that will off. So now this one only on. Okay? Okay. Then this one is the counter for each DT lah, right? Okay, okay, go down. Now also okay. Now we know GT is on. Okay. So now this one is what? Tell is what?
Telescope.
Okay. So telescope on position 20. Okay, this one is the SR40 set. Okay, good. So what they bring here is, okay, if let's say if it is at 20 or 40 lah, right? 20 or 40, and must be start and must be G, I mean the test must be on lah, right? So this one must be on, okay? And the position must be 20 or this one. Then I need to press start, but not sure where I need to press start. Is it a block I'm using somewhere? No, right? Oh, okay, okay. If the counter is 0, okay, yes, okay, good. So it's already means it's in start position lah, right? Start position, and your test is in on condition. Then if one of these the telescope is in one of this position, I put a 5 second delay. Then I set 40. Okay, earlier on top I set on, right? Here I set 40. Okay. At the same time, I on a memory as well. Same like just now the DT on, right? Here is the DT 40. So first is the first condition, is the on condition. Second is the 40 condition. Okay. Or so the 40 will be set if must be in start, must be the counter must be 0, must be in on condition, or either one. Any position lah, right? Okay, 20 or 45. That is the one condition. Second condition is the what just now when we on the GT on, right? We on the do test, correct or not?
Yeah.
Okay, at the start, but must be in CM is what?
CF is change mode.
Change mode. Okay. So change mode. So now the thing is, okay, now we need to know who on the SR40, correct or not? That's how we need to troubleshoot. Not need to check lah, right? Okay. So if I want to on the SR40, the first thing is, okay, one of these must be on, must be in counter must be 0, but must be in on condition. After 5 I on. Or another one is must be at correct position, must be what? Telescope at correct position. Or this one is N lah, so all of these must be on, except this must be off lah, normally goes, right? So if these two condition is off, then only I on this. So who reset? When I reset is when this one, what is this? The test is on, I reset. Means this is the initial one, right? Right. So this is the first position, 40. Okay, go down. Then okay, same. When it's 4, just now is go up 45, right? 20, 45. Okay. Now here is if 20 or 40, same thing. Then I will on the position 45. Correct. Okay, just now I on the position 40, then 45. Okay, go up some more. Okay, the counter is okay. This one position, right? 40, right? Okay. Then it count 1. Once this one done, okay, go down. Then go to second 45. Then this one on, I count 2. Okay, go down. This one is the position 20. It's the same thing. If it is 40 or 45, so I go to become a reset lah, right? If 45, I need to reset. Maybe I think it's a 45, right? It's the maximum forever. So I reset. If can you see 45, I reset, then reset, we reset this. If 40 only, I reset the 20. Okay, at the same time here. Oh, this one YB.
Okay, so maybe
Maybe by mistake. This is the just now I tell you, right, the IEC. IEC 1611-3. This one GD20. That's not by mistake, you put C. Okay. Actually, what you can do, normally what I do, I will save this into another folder for testing, for training, so I can just play around there. So original one I want this. Okay, so this one is, so first 40, 45, now 20. Okay, so if the counter is 1, right, means any of this is on, counter become 1, correct or not?
Yeah.
Okay. Then when the so at correct position, TW is what? Please stop. Okay. Please stop is all unlocked. Then I make it compare. I mean, this is the condition lah. This is I compare. Then this is the condition. Interlock lah, right? Interlock, and I on the lock. Right? You go down. Same thing here. When the value 2 means it's like so two position done already. Because actually you have only 3 positions, right? 20, 40, 45. So if 2 position done already, so if 1 position done, I do GT lock, right? Okay, and I need to see where I use this one, right? Then if 2 position done, then I unlock. Then if the 3 position is done, then I go down. Then 4 position down, then I go up. Okay. Then this one, I think this 1, 2, 3, 4. I think they're using for counter. You go up or here? Go up. Is it they're using for counter? Yes, for counter also lah. Right. So first 45, okay, count 1. Second 40, okay, count 2. Third 20, okay, count 3. Right? Once you lock, then count 4. Then unlock. Okay, so
I
they
think only start here, then you start to count.
yeah. I mean, you mean what?
The lock, unlock, then you will start to count 1. Lock 1, unlock 2, then the following.
I don't think so.
Because I know how the endurance test is done. Maybe you will open until maybe now it is 20 feet. Then you will open for 40. Then you will lock, unlock, triple down, up.
Yeah, that's why I say any of these.
Oh.
But three, right? Any of this is on, you go down. You see, I count. So any position is on, I count 1. Correct. Then I lock. So lock means then the counter become 2 lah. Correct. Then when the counter 2, I unlock. Unlock means counter become 3. Then when counter become 3, then it's go down. Right. Then when it's go down, counter become 4. Then when the counter is 4, then I go up. So this one is in sequence. Correct. First lock, then unlock, then go down, go up. But to do the lock, I must be in 1 position. Any position that must be from maybe from 20 to 40, or 40 to 45, or 45 to 20. Any of this position, I count 1. That's why the first 3 is the to know which position. The first movement lah, right? Because you see, because from here we can understand that we go up. Because that's why they put it here. Okay, you see, to on 40, they put 40 or 20, right? To on 45, okay, 45 or 40, so here. You see this one, okay. So if I want to energize 40, my position must be at 20 or 45. Then I energize the 40. Okay. So if I want to energize, if I want to go to, let's say 40, if I want to go to 45, my position must be 40 or 20. Okay. Then you go down. Then if I want to go to position 20, my position must be at 40 or 45. Here. And here they put and, right? Maybe this one maybe I can write down like this. So the first one is the and. So means okay, okay, when it's at 20 feet and it is not the 40 must be not on. Alright, so must not be the 40 feet. This one is the set lah, right? Must not the 40 feet not on. Okay, then or the position must be at 45 feet and it is not the position set at 20 feet. These two conditions. Then only I do this. Okay, then or function, right? Any of these, or then must be in start mode, must be start, then must be the DT must be on, right? Then the timer. Okay, let's say I make it into our logic ladder program. Okay, then let's say I put the timer TON Q output, right? Now take the TON Q. If the TON Q is done, or this or function I have. So this one is the not okay. So the what they call the telescope at correct position, right? But it's not normally closed like because it's an invert, right? Okay. When you tell it at position and the load test is on or the single load. Okay. It's to or. Then I energize, I have output lah. Then me I use I set at 40. Okay. Then reset we don't care lah. Okay. It's a reset. Reset is because first in the reset actually got two. You must come from here lah. That is must be reset or if at 20 feet. This one is showing that at 40 feet. And this is the set reset at 40 feet. Okay, so it means what they try to do is so must be at position 20 but it's not already go to 40 already. Means the same thing I have for all the three, right? So it means what must be at 20 position and it's already didn't move to 40. Then only I can move to this is the first one, right? Yeah. Okay, then only I need to move to 40 feet. Or the position is 45 but it's haven't moved to 20 yet. Then I move to 40. So this is count as so the same interlocks they do for the 45 and the 20 also. So make sure okay, like what I understand now, right? Okay, so let's say this is the 45, this is 40, this is 20, right? For example, the distance, right? Okay. So this is the 45, this is the 20, let's say this is the 40. So if you want to do this test, right, because I want to count from 1, 2, 3, 4, I need to go step by step. Okay, so must be from here to here, or from here to here, or from here to here, or from here to here. Any movement. Okay, so from any movement, and then once I complete my movement ready, I count 1. Right? Okay, go down. That's what I'm doing the counting. Okay, so once I count 1, I lock. Right? Okay, so lock means what? What do you do? Which one? There's twist lock lah. Twist lock is what actually?
To lock the container.
To lock the container. Okay. So, so any position is moved, okay? Then it must go down, up and down, right? No?
Up and down.
The
The twin.
ah.
Twin only will go for 40 feet.
No. I mean this one, right? This one is you are testing the, I mean the moving or go up and down. So
Moving on.
just open. Okay. So from one position I move to another position. Okay, I lock, right?
Yeah.
Once I lock, then
Unlock.
is it immediately unlock?
Yeah.
Immediately unlock within 3 seconds.
Yeah.
Okay, because I can see the timer here. Because you see, the moment GT lock is on, so the counter value become 2, right?
Yeah.
2, and this one is all position, and I will get all lock signal, right? So once I get the signal, okay, after 3 seconds, it's the off. So this one will be on, this one and this one is already, I mean the testing is already on, right? So we'll unlock. So means I lock, after 3 seconds I unlock. So once I lock, I will wait for this signal to come in. Because once I lock already, the counter become 2. Right, so this one, so my signal go and wait here. And this one, okay, I think it's already on because it's already on here, right?
Yeah.
So on. Then I will wait for this signal. So I'm not sure how doing this one, how I get the signal, okay? Because the twist lock, all locked, right? Okay. Then I send the signal to the timer. Timer will start to run. Then after that, the timer will see signal. So I don't get this one because it's an off function. So off function is straight away on, then example. Or this one is off. If all unlock ready, okay, this one is I think the initial lah, right? So this one I think is initializing the system. Okay, so once I unlock, the value become 3, right? So when it become 3 and I'm at my position, I wait for 5 seconds. Then it's the off function. I wait for 2 seconds, not wait for 2 seconds, for 1 second it will go down, for 1 second. The FL is what? Flipper. For 1 second go down, because I can see TP, right? So TP means the moment it's on, this one on, because this one is already on, right? Already on, so this one on for 1 second only, right? So this one will on for 1 second. Go down. So once this one on for 1 second, the value becomes 4. Then I wait for 8 seconds. Then the flip up also will on for 1 second. Because you can see here, it's on, then off back. That is the symbol here. Okay. Now until here already done. Next. So here is, so if it is at 40 and this one is on, I will set. Means if the position is at 40 and it will already done these functions, right? Then the twin is ready. Correct. Ready at the same time, when this one is on, my counter value become 5. Correct. Okay. So when counter value becomes 5 and this one is already ready and my position is at 40, then I do this job, I do the twin LUT, right? Okay, I just on a memory. This one is like a status LUT, right? Okay, go down. When twin on, then the counter, because all these going to the counter, correct or not? So this one becomes 6. Then when the value is 6 and at the twin mode and all the twist lock is all unlocked, then I on the twin lock. This is a memory only, so it's not controlling anything, right? It's a memory. Then this one of course going to trigger the counter again. So when the counter is 7 and this is the value, I go to extend. So extend means what?
The twin will be extended.
The twin will be extended, right?
Yeah.
Okay.
Extend to maximum and
Oh, so extend to maximum, right?
yeah.
So once I extend to maximum, I will extend for 12 seconds. Because this is the one going on. Then after I reach, then after 5 seconds, then I retract for 5 seconds. Right? Good. Then goes back. Then this one going to counter the counter value 9. When the counter value is 9 ready, and this one is what? Twin mode, yes. Then all is unlocked. And GT retract is off already because here it is on for 5 seconds, then it will off. Correct or not? It's off already because the moment it's on, this one become 9. Correct. So this signal is waiting, this signal is waiting, this signal is waiting. Okay? But the moment after 5 seconds, the retract, this signal will off. When this signal is off, then only I run for 5, I on a timer 5 seconds, then I on this twin unlock. Okay, go down. So it will count 10, right? So it will count 10, then the 10 go to flip down. Then this when this one is on, then it's flip up. And when the flip up is on, going to single. So go back to single, is it? Go back to single. So now at 5, if it is at 5 or at 13, right? And at single mode, I reset the counter. Then the counter reset, fully reset. Then again we will count, right? Again do the, so means it is just a process only, right? So as what I understand is okay. From any position, from any position to go to next process, I mean any position, then I will flip up, right? What is it? What do you call? Or lock first. Okay, I lock. Then after a few seconds I unlock. Then I flip down, flip up, right? Then after that go down. Once done, I become twin, right? Then I will twin lock. I lock the twin, then I will extend, then retract, then I unlock the twin, then flip down, flip up, then go down, then so just now it's a twin, right? Then it becomes single. Is it? Go back to single lah. Then I reset the counter. Yeah, it is in sequence lah. The first three only is like or means this can be this, can be this, or can be this. Three positions.
But the first three, how I know the sequence is?
It's not a sequence.
No sequence.
The first three is not a sequence. It can be anything.
No. When we start the process, right?
Mm-hmm.
You will be go to some position first and following the next. Will be follow this.
I don't think so. Because you know why? If any one of this is on already, the counter become 1. Right? Then you go down. If the counter become 1 already, then I go to lock already.
But it will not be, for example, now it's in 20, then it will go to 40. And
not in the 40, right?
Yeah.
Okay, this one is must be in 45 position, not in the 20 position. Okay, I start. Then I move to 40. That is this condition, right? Okay. So when this condition means either I must be 20, I move to 40, or I must be at 45, move to 40. I count one. Okay? Or so because I don't know at which position I'm now to count. Okay, so let's say first thing I am at 20. Okay, I'm at position 20. I move to 40. I count one. Then once I count one, because I already at the 40 already, right? So the 40 and it's not 45. Of course, it's not 45. Then I'm not at 20, correct? I'm not at 20. So this one won't work, right? Okay. Let's say I first do this, right? Okay. First we see. First let's say I'm at 20. Okay, so I'm not at 45. So this function won't work. And I'm at 20, so it's not on the 40. So this is not right interlock, okay? I mean normally close. So I'm at 20, okay, then I start 5 seconds, I go to move to 40. So now I go back to 40, okay? So if I'm at 40, means this one can on, correct? Of course this one cannot on already. So I'm at 40, then I move to 45. Okay, then this one will on. Go down. Now I am not at 40. Correct. Now I am at 45. Correct. And I must be at 20. You see. So this one is I must be as 20 because here is not that. Can you see it's not? They didn't put the the end gate. So if I want to energize, if let's say if I want to move to 20, means my position must be 40 and the 45 is already done. So it means this sequence must be done first, means it's a set, right? It's a set, it must be always on. Then I move to 40, means yes, then I can go to 20. Only the first one is the OR function, yes, you see. Second one is like this. Okay. I must be at 40 position. Of course not in the 45, right? And I either one lah. So if the 40 position is already done and I am at 20, I must move to 45. So it's like how they do is okay, let's say all the set all is not set yet. Okay. So first thing is, okay, let's say I'm at 20, okay, I move to 40. So when the 40 is on, I'm not at 45, alright? Of course, I'm not at 20, and 40 is already done, correct? This one is the set reset output, right? The 40 is already done, but I'm not at 20. Currently, I'm at 40, and I'm not at 45, yes? I move to 45, then the 45 is done. The 45 is done. This one is energized, but I'm not at 45, but I'm at 40, right? Sorry, I'm at 45, right? So this one won't work, right? Then I'm 45, but the 20 haven't done yet. Correct.
We'll go back 45 to
So, no, it won't go back to 20 actually. Because if you see, this one, right? Okay, this one, of course, currently I'm at 45. So, my current position is not 40. Okay, so this one, of course, it cannot on. If this one on, of course, this end won't work. Okay, now we see here. My current position is at 45. But I haven't done the 20 one. So this one also won't work. Correct. The signal won't go here because I'm at 45. Yes, correct. But I haven't energized the 20 yet. So this signal won't give the output. Here also, I think it won't give the output because now I'm not at 40, I'm at 45. Correct. When I go back to the 40, then only I can energize 20. So I think it is 45 the thing because it is like, okay, this one is like go back to 20, reset, right? So this one is go back. So I think it's from the 40 it becomes 45. Or from 20 it becomes 45. Okay, so it means here we go up. Means if it is at 20, I go to 40 first, then from 40 I become 45. Or if let's say I'm at 45, I'm already at 20 already, right? You see? No, sorry, I'm not at 20. 20 is haven't done yet. Let's say I'm at 45, I go back to the 40, then of course I will be at 40, then I go back to 45. So it means somehow it's like go to 45, fully open. Okay? Then only I count. But you go to counter, because on the counter count when I go to 40, okay lah. So on I count 1, right? Okay, I will count 1, okay, go down. 45. The one. Then you could, let's say this is running for, start after 5 seconds, I move to 40. Once I reach 40, example, after 5 seconds, I move to 45, right? So total for 10 seconds. Okay, go down. When I count 1, and must be at correct position. How I know it is at correct position?
we have
Sensor.
to detect now is what is the position.
What is the position? So whether it's a 20, 40 or 45, right? Okay. But how I know which one is the correct position? Is it 40 is the correct position, 45 or 20 is correct position? Yeah. Okay, right. Where I write is, oh my god. Where is it? Here. Q expose. Must be out to see it out. Q exposed. So very big one, huh?
Yeah.
QX. 45. Okay. So in any position now. So I think it's like I said, man, it's from any position. From 40 become 45, okay. I can start the job. If 45 become 40, I can start the job.
Yeah.
40 become 20, I can start the job.
Because it must be any possible position, all must be done.
Yeah. So there's no sequence here.
No sequence.
I mean all these three, right?
Yeah.
It's not sequence. It's depend on, okay. When I start this test, when I start to run this test, I will check from what's my current position now. So it is either 20 or 45, means I will move to 40. Okay. If I am at 40, I move to 45. That's all. Because I say you go here because if I am at 40, I can move 40, 45. Or if I am at 20, I move 45 also. Correct? But the thing is, if I am at 20 and I haven't done the 40 yet, correct? So this one won't go. So it's here. This is, I think, the first sequence. If you ask me sequence, I think this is the first one. Okay, let's say we assume it is in 45, for example. 45 of course, it go move to 40. Okay, let's assume it is in 20. To 20, okay, yes, of course, move to 40. Okay. Now let's say it's in 40. Of course, this program won't work. Correct. Okay. Now let's say I'm at 40, and if I've already done the 40, so I haven't done this one, correct?
Yeah.
Okay, so this one cannot work. Now I am at 40 position. I only able to go to 45. Okay. You go down here. This one is if I am at 40 position. Okay, now I get some idea. If I am at 40 position and I already done the 45. Okay, right? If I, let's say, initially it's 40, right? Then I go to 45, right? Means 45 lah. Then you go back to 40. Then only I go to 20. Means I must go to 45 first, and now, so means this one must on first, correct? On. Okay, so means from 40 I must go 45 first. Then when let's say I go back to the 40, then only I can go back to the 20. This function. The 20 is the one problem. Not problem, it's like it's optional, because if I'm at 45 and I'm already done the 20, then actually why I need this? If you ask me, because I already done the 20, right? Then how can I on again the 20? So means this one also won't work. It means from 40 I become 45. From 45 I become 40. Then from 40 I can become 20. So it means I can be any position. The first movement I will move at is go to 40 first. Go to 40 first. That's first movement. Then I can go to go to 45. Yeah. So this is considered like from anywhere I go to 40. Right, okay. This one is consider how we go. This one is if let's say I already at the 40, I've done the 40 and I'm at position 20. So how can I go to 20? I cannot go to 20. So if I already at 40 and I haven't done 45, okay, I will go to 45. That's all. So it makes very simple. From any 20, it become 40, then 45. Then only it start to do the job. Or from 45, it become 40, then 45 again, then it will start to do the job. So it means that at 45 only it will do the job. In solar, that's what I believe. If I see, that's how it works. And I'm not sure how it works. Because now the question is, go up, because now the question is, the moment 40 on, I already count 1 already. So the 40 is like always on. So later on the 45 is on also, it won't count. Because counter is, this is an off function, right? Only one signal, then I count 1. Then you off, again another signal, then only I count 2. Okay? Then, so it is, go to second one. This one is, that's the thing. Go to 40 first. If it is already at 40, then you go to 45. It is too early. If this one is, if already at I already at 45 already done, and I move to 40 already, because I'm not sure how it moved to 40. Right? Because it can be some other things, right? Move to 40. So when you move to 40, then the 20 will come. So this is not a sequence actually. If you ask me, I'm also very confused. But the first thing is moving 40 is the first one. That one I know already. Moving, because they use a not right. across means it's either 20 feet or 40. So either any position. Here they already fix a position. Means it's already reached 40. Means this is the first position. This one I can tell you like this one is like the second position. This is the first sequence. Second is can be this or that. Can go to 45 or 20. Okay. Now this is not a function block, right? No. So just pass. This one is the tell position. Tell. Is it your name? You key in tell dot x position or just the name is x position? Tell is I know tell is telescope is I mean this tell is it function block? No. You open the function blocks. Any questions here? You do you have wiring diagram for this? Wiring diagram.
Yes, but it's for radio side only.
It's radio side only lah.
Yeah, it's how they go to connect. It's this one. How the component is one, the fuse. This one is what? Is it the IO is Siemens or EPAC? How many are you? It can be SM1 until 3 and 1 got 1 point something. If how many IO I'm not sure.
Okay, very good. Go in front. This one is the motor transfer cable. Okay. This one is power supply.
No, it's
Oh, this is the STI can to can. Why STI? Why you must use this?
this is for communicate between the spreader and but mostly it's manager people.
So this one is. So normally, what is the issue you face?
Like this on this is a program I write, but I actually not my write. I copy from another project and I modify and see where it to add some input or output. So I just know how to copy and paste on it.
Okay.
So sometimes I ask my senior to explain, only explain the overall, the summary.
Yeah, that's the thing.
Yeah, so I'm not sure, then I keep to ask them, you got many job to do, right?
Yeah.
So
That's the thing because see, as I said, because this one is because of course I know it's not other people's program, right? You cannot understand other people's program.
Then he will ask me to write by my own, but the thing is I not really understand how can I write by my own.
Okay, when you want to write your own, the most important is the flowchart.
Yeah.
But for this, you cannot do like one flowchart. You must do like multiple flowcharts. So okay, let's say for the testing, right?
Yeah.
Okay, the testing itself. Okay. First thing, okay, you need to do like a flow. Okay. Now I start the testing. Okay. So now, actually here, okay, example for this itself, it's like there's so many conditions. That is okay. If I want to start, okay, how it start? Okay, when the counter is 0, I start. Okay. Then, let's say the first thing is I want to move to 45th, right? Now, I must put, okay, if I want to move to 45th, either I must be at 20 or I must be at 45 feet. That is your flowchart, the first thing. Okay? Okay. Then, once it's okay, let's say it's already 45. Then, the counter is already 0. Then, in the status is on state. So means it's already at some different position, right? And the counter is already 0, and I'm already on state. I run 5 seconds. After the 5 seconds, first I do this. If let's say if you want to write your own run, very simple. First, okay, of course you do this lah, either one, correct? These details you know already. Then this one. Then of course normally you just put set directly. Okay. Then later on you add this, the OR function. Because any programmer they cannot straight away add this. Okay. So for example, I just do from what I understand from here, right? Okay. So I just do in the ladder. So from what I understand from here, okay. So you don't care about this lah. Okay, the counter is already 0. Okay. The D on when I get, I get when is this signal is on lah, right? Okay. Let's say it's already ready lah, right? Okay. Already get the signal. Is waiting for the position now. Which position? Okay. And when the counter is 0, as 0. So when the counter becomes 0, you go to who reset the counter? Go down. When the GTD not on, or it's on, okay, let's see that. Now what I do is go back here. First thing is, let's say I try to do a flowchart. So if I want to, my idea is very simple. Move to 40 feet. Correct. My idea is very simple, move to 40 feet. Move to 40 feet. But how? First thing is, it must be at 20 feet. Okay? But not 40 feet. Or must be at 45 feet and not at 20 feet. X is not right, okay? Either one, or function, okay? Then second condition is must be in start position and the GD must be on. Okay? Then what I do? A timer. Timer, okay. 5 seconds. So if the timer done, I move to 40 feet. Okay? At the same time, I'm on the DT40 signal. Okay? Then this is to first to on the 40 signal. Okay? Then the second whistle, what? It's a single mode, right? So I can, the 40 feet can be on from these guys, or so here like the condition that is not at the correct position. Okay, it is not at the correct position, and plus must be in do test, plus it must be in single mode, right? So if it is not at correct position and you on the do test and in the single mode, I can move 40 feet also, or this way. Okay? Then who off this? 40 feet. Who off into somebody who off this, right? Like just now, we start the valve A, someone need to off the valve A. Right? So if I want to stop, so 40 feet is on, right? So if I want to off the 40 feet, if I want to off the 40 feet, what I need to do? I either on a reset move function plus my DT one has been 20 feet. Okay? Or the root test must be on. Okay, then I reset the 40. So this is the my flow chart. So first I need to do the flow chart. From the flow chart I can do. So you can do this way, or you can do it ladder. And this way also. If you ask me, the programmer, earlier programmer, you know what they do? Of course, they straight away won't do like this. They will do okay. Maybe until here they do first. They do okay. Of course, maybe they know this right. Of course, this is the sequence, right? They don't have this first. Correct? The first thing they have this first. So what they do is off function or a timer straight away set. That's all. Then of course, if you want something, you need to off something. Now, once the off function is okay, now you add this. Okay. Now, okay, let's say I said if 40 position, if at 20 or 45, okay, move to 40. Right. If let's say, if not in this, because it must be start and the GD must be 1. If not in this sequence, but I still want to move to 40. That's another sequence. That is, if it is not in the correct position, means there's no position. It's not 40, not 20, not 45. Means, of course, these two won't go. So, if it means it is not in these positions, and you already you on the do test already, okay, then it is in single mode. It's not in the twin mode. Single mode. So I go back to 40. So that's how they end. You cannot one shot you do like this. Okay, they will think, okay. First, of course, there is actually, if you ask me, of course, the first they do this one only. First they do this. Okay, at 20 and not at 40. They do this. Actually, initially they don't have in by imagination. Initially they don't have this. They have this and or even these two no need, because these two end right. I can add here also. So if all the condition, if let's say we take out this, must be at position 20, not at position 40, but we at start, must be GT on, timer run, I said. They do this first. Then only they add this. Okay? So it means I erase this, just put it in. How they do in my imagination. First, they put it A and B. First, okay, must be at position position 20 feet, right? Okay, and I just put this is a not, so it's not yet go to. Actually, this also sometimes they don't have position must be 20. Then must be in start position, and the DT must on. This is the first initial sequence I have. Okay. Then timer 10 seconds. Then SR. Set is up. That's the first thing I do. Okay. Now because actually how I get this? Ask me now. How I get this? This one is from here, right? I ever do this one. How can I put it here? Logic, right? I ever do this. So this is the SR40. I ever do this. How can I put the SR40 is not? Cannot. So first I must do this first. Then of course, then I will think, okay, reset. Who need to reset? First what I do, normally I just put first reset the move first. Because why? Because the GDT20, right, is from the third line. I haven't done yet. You remember we do this after the timer, we use the motor off. Then only we use on the top. But initially we know we want after the timer want to off the motor, but we don't straight away put the timer there. We create the timer. From the timer we create the output. From the output later on we use that. So that's how the program goes. So initially you do this. You put reset move first because that's the first thing maybe you add. Okay. Now we continue. So let's say now this one is position 20. So now I have this one. Okay. This one position 20. Then maybe you try to create another one. Maybe for position 45. then you see the sequence is the same thing, right? So now only you do this. The A and D. This is the position 20 feet. Now this one, now I can get the SR40 here, not now. Then first this. Now what I do? I have another one. A and B. This one is the position 45, right? And it's not the SR20, right? Not the SR20. So this is, so now it's not an and, must be either one. So I put all functions. Correct. That's how right. Okay. So first, then come here. Okay. Now, so what I want, because now I say I want to do the counter, because on top I have a counter, right? So actually I can use this, but this one will be like a set. So even though this signal is already off, this one is always will be set. So I don't want to use that. So what I do, I create one DT, I mean a done lah, for example lah, okay, done 40. Okay, then now I have another thing, that is, this is the, if at 20 I move to 40, if I am at 45 I move to 40. Let's say, that is, so now this one is until here already. Now let's say I am not at a position, but I want to move to 40. So what I do, of course this sequence won't work. So now I am not at a position. So that's where that's where I add a here the OR function. Here, okay, what? This one is can be and or is depend on the interlocks. Right. So and what is that? So must be the load test on, or must be the single mode, and is not at the correct position. So this one, to do this one is an automatic, actually. It's an automatic. Right? Because for this, it must be, the DT must be on state, the counter must be at 0, then only I go to 40 lah. This one is automatic. So if let's say it's already misaligned already, automatically go to 40. Then now actually finish now the reset, right? The reset also same, you know. First the reset, what I do now, first I just do the OR function. That is the OR function. One is the reset, the move. One is the timer, right? The TOF is from the design DUR. Okay, because if it is finished already, then I can reset it. Because I need to move first. Correct. I move first, then I need to reset back this signal. Then only I can know where I want to go. Then why this one I didn't add? Because this GT20, right? When I do the third line, then only I get this. So when I do the third line, I know, wait, if this one is at 20, I must reset the 40 line. Then only I go there. Then once I do that, from there only I take an equation. That's how the programming is done. So when you see this one, don't scare. But if you want to do yourself, don't scare. Okay, of course, this one, of course, difficult to understand. Because it's, that's how the programming, right? Because if it is one line, it's not like everything is here. This one is from the third line. This interlock from the another block. This interlock is from the function block. Something like that. So we don't know how they do the program. So that's why always don't try to understand their programs. Very difficult. Can lah, slowly need to learn slowly. But when you see like this, don't scare. That's the thing. Okay, because I know sometimes my participants they show me like this lah, but not code disease lah. Code disease lah, I think after 5 years I'm seeing code disease. Because during the COVID time only I teach for the Indonesia. After that I no more teach because mostly I teach what? Omron, WinCC, all that they have their own software. Only last time I teach this one because they are using backup software. The backup also they have their own software. So you can use their own software TwinCAD or the code disease. So I teach them both. TwinCAD also same thing, exactly same thing. Everything is same. Only different is here, right? You have a POE, that's what. They have a configuration settings, that's all. That's the additional. So normally participants they show me normally other PLC programs are like PI400 show me like and normally they use ladder. Sometimes so big they also confused, they also scared. Don't scare. Of course I know this one is difficult to understand because even expert also cannot understand. Because we don't know how they do the program. If let's say I only see this program looking, sure I would understand. Because why? I don't know where I get this from. I don't know where I get this from. Maybe from the top I can understand the start, the GD on I can understand. But the rest I cannot understand. Okay, good. But if you want to do program, if you want to do a project, you need to have a culture that's the best thing. You need to have a culture. If you know very difficult to do. Because even in the flowchart also, sometimes they don't have this, sometimes they don't have this. An example like this one. They won't give you this. Okay? Like example, we do which one? The mixer tank, right? Actually, our mixer tank project yesterday we do. Yesterday, the day before you do, it's like very simple. Correct? It's very simple, not this complicated. But I can make the program complicated. Means I need to think of every possible fault can happen. But that day when we do, we just start, okay, low level on, then okay, high level on, okay, done. We haven't tested, suddenly low level on, what happened? Suddenly high level on, what happened? Suddenly I on already, but mixer is not working. How? Mixer, the actual mixer not working. But here the timer can run. After that the timer we can on back the pump. So if you see all that, then of course you need to add more I/O because if the mixer is on, I need to get the feedback from the mixer. Is it running? I want to on the pump because mixer and the pump you are using. If let's say you are using direct motor, direct online lah, they call DOL, means you can get the feedback from the contactor. You can send the signal to the contactor to on the motor. So when the motor running, then from the contactor you can get the signal. Pump also same. Or let's say the motor, the mixer and the pump you are using frequency drive, okay, VFD, then from the VFD you can get the feedback whether it's running or not. If it is a fault or not, then you need to add all the additional I/O Then if you do a program, then it will be very, very big program. It will be so much complicated. Even the starting itself, yesterday when you start straight away the valve on, right? If let's say there is a water inside, already high level, already low level, so you cannot start. So all that you need to do in the flowchart, because yesterday the flowchart just make it simple. But the actual flowchart, I need to do that all. Okay, when I start, I make sure that this when I want to start, I make sure all these right condition. Same thing. When I want to start, I make sure the low level is off, the high level is off, the pump is not run, the mixer is not running. Then only I can, even the valve P also is not in running. Then only I can on the valve A. So if the valve A is on, it must be within 5 seconds need to reach the low level. If not, because I don't know whether the valve is open or not. That's why they have put all the timing, everything and all that. Okay, good. Any questions? Any other functions you want to do?
I think I already asked.
Oh, I already asked about questions. Okay. Please control. Please stop. This is the program, right?
Yeah.
Okay. So normally this one all you don't touch, right?
This one, yes.
Mostly you do the just now you said the PXRS, right?
Yeah. But sometimes there will be some modification, so maybe I will touch some.
Modification means or modification you modify the logic or the name.
Modify the logic.
Okay. How?
But I will ask my senior first.
Oh.
Is it my suggestion is okay or not?
Oh.
He will decide need to change or not.
Oh.
Yeah, but I will give my suggestion first. Yeah.
Your senior is the guy who attended training here.
Yeah.
Is it?
Yeah.
Oh. Malcolm.
Yeah.
Okay. So they will check whether you need to change or not. Even you can test. But how you test if you want to change?
I will test
Simulation.
No, I will online and then direct change and I will test on spreader.
Oh, directly on the spreader.
Yeah.
Oh.
If there is work, then I will tell to him. Yeah, then he will decide want to change or not, or no necessary.
Not necessary then no need lah.
Yeah.
You just go online. So it means it is in your factory lah, right? The spreader, right?
Yeah.
So you just go and change. If it is working, and if it is okay, then you keep it lah.
Yeah.
If it is working but it's not necessary, then take out.
Yeah. Something like that.
So you understand the dysfunction, right? The equal,
Yeah.
greater than, all that. You understand, right? Okay, Siemens also. Go to Siemens. Siemens also they have a comparator. Yes. It's the same thing, but because I see here they have a lot of signals only, right? There's no like values, not much values, right? Is it got a lot of values?
Yes.
Where is the values? I want to see. Set points.
Yeah. Set point, the ruler. This one.
Calculate position to train. Calculate twin position to train. This is the actual duration? Counter 4.
You can know how much the screen total. What
Okay.
is the mm?
What is the mm?
You will count in mm.
Here or this one?
Out.
This one is in mm lah.
Yeah.
This one is from the actual.
Yeah.
I get it from where?
Actual, we have the cylinder for the Google.
Yeah. No, I want to check from where I get. We go to right. Yeah. Oh, here. So QI position. Find QI position. QI dot position. Sorry.
QR code.
Yeah, QI was. So position 1 over. This one they changing the data format. I mean data type. Integer to double integer. So you know which one is integer now? This one or this one? Okay, very simple. They convert integer data to double integer. Okay, so now which one is integer? This one or this one?
This one.
No, this one. Because they're using structured text, right?
Yeah.
So structured text means if I put 2 dot equal means this is my output.
Oh.
So my output and the command is integer to double integer, and what is which one I want to change? This one. So from here I will convert to double. That's why, if not mistaken, they put the QU here. It's a double. So if this one true, okay, go down, they do calculation. Okay, go down. This one is normal, normal programming. See, if this value is to equal lah, they're using a comparison here, right? This one is a OR function. If so, this is OR function, and this is this, and this is like AND function, but this is a NOT lah, right? Then if not and this, so they use the OR function, AND function, then finally this is the output true, right? But they simply do this because copyright is 2016. So who built this one? Malaysia or Holland? Holland.
Most of the function block is built by Onsite.
Most of the function blocks are. Actually, these blocks, all right, these blocks are. It's not like they build it today. It's like, okay, you know how it was. Earlier, let's say you go back like 20 years back. Of course, 20 years back also they have a crane, but which is more simpler, right? More simpler. So, of course, they might use something this this type of PLC or another type of PLC. So they just yes, okay, just go down. Once you go down, okay, then they must have like manually move everything. Correct. So means okay, so they have multiple inputs, then multiple outputs. So they just press go down, okay, go down. Okay, once I reach the sensor, okay, then I will see there will be a LED, okay, at position, right? Then I press grab, flip or something like so. Means 20 years back they have a program that is like manual. After that they come out, they use the same program, modify it a bit, make it into auto. Modify. So the same thing you are doing now. As you said, it's already F. You copy, you put, you modify. So it means this machine, the program you build is not today's program, for example. Actually you also don't know. They put 2016 this one. So maybe more than that. That's why when some people see the programmer, they say, oh, this programmer must be very awful programmer. He do everything. No.
Yeah.
Cannot be. And another thing is, if something like this, right, it cannot be done by one person.
Yes.
That's why they didn't put the name, they just put vertical department. Because in Siemens, each block you can put your name. If you build, you can put your name. So I've seen some company machine, they a few blocks with different names. And some block, of course, is Siemens one, they put Siemens. Some block different author. So maybe they do for this machine, and it needs something similar to this machine. So you copy the particular block only. You copy the particular block and use back here. Then only. Even I also do the same thing. Whenever I do a project, let's say I'm doing some similar project like temperature control. So this project also for temperature control. This project, let's say pressure control, but the concept is same. So I don't need to rewrite it again. Just copy the particular block which I do the calculation for temperature and use back here, do some modification. Okay, that's how it goes. So don't scare off when you see like this. Don't ever scare. Okay, slowly you learn, then you become a program. Okay, because we said you already put the function block and they using in ST like structure text. Okay, good. Yes. Take a break and after the break. show you some animations. Go to the basic instruction. Okay. Then you go down, convert. Yes. Convert. Just now you see right in your one integer to double integer, right? So you can use this convert function. Yes. You take the convert here, put it here. So directly can choose from one to one convert. So they don't have like a function called integer to double integer to, but in structured text, yes. If you're doing SCL programming, you need to do that. That's not int to double integer. So here is different because the previous version, the one is using this PLC, right? The 300 PLC, this PLC is using different. They have all the convert function, integer to double integer to real, all that. So let's say I choose one here. Let's say integer. Yes. Then choose real. Yes. So let's say you want to do some calculation, for example. Let's say you put it nice function. Divide. Yes. Okay. Then divide, you put choose real. So let's say the data I get is in integer. Okay, let's say you put some value, let's say MW100. MW100. Then this is real, right? Must be real. So MD102. Yes. Then this one is MD102. No, 102. I want to use back the same thing. Then this one may be a constant number. Like example, 3.0. Yes. Then finally the result. Okay, another MD. MD106. Just download this. Monitor. Oh yeah, cable. Just key any number here. Okay. So why? Because I want to divide. Right. I want to divide a real. Okay. So it cannot be a integer. Right. You can put an integer, still can, it won't show error, but sometimes cannot get a proper value, okay, proper number. So what we do, we convert the integer to real, then the real I can use for calculation. So this is the convert function we use, okay, because we will see the data type is the problem always. If you didn't put the proper data type or you didn't put the proper addressing, then you won't get the value. Like yesterday you try, right? If you do one mistake in the address, then you cannot get the value. Okay? So there's a lot of functions. Actually here also got function block, go offline, I'll show you. Have you done it before? TI portal function blocks. Go to add new block. Function block. Sorry. FC. This one you will put FBD function block. Everything is same thing. Okay. Then this is the AND or then there are some other functions. This one is an invert. Additional then the output. So for example, I want to do like this. Okay, you just take the AND. Yes. Then what is the AND function? Let's say we just do a simple. No need to do this. Okay. Let's say M10.0. Let's put M10.0. M10.1. Yes. Then let's say we take a OR function. Yes. Then this one and not here. Then 10.2. Yes. Then you can add a timer. Actually, if you choose this position, like you just double click. No need to drag actually. No. You choose this position. Double click this. Okay. So then here you put the timer value, 10 seconds, then ET no need. Then the output you add output. Yes. Then you can put the output here. Q1.0 for example. Like this. Okay. You can change to ladder. You right click here, switch language, ladder. If it is able to change, can change that. Cannot, if it's not able, off. Say no. Can change. Because you know what, the previous one, like this the 300 S7-1200 is using SIMATIC manager. That one, yes, cannot convert. You know why? Because that one in one network I able to do one line only. Means like how to say, like one rung. This is considered one rung, right? Even though I have multiple branches, right? It's considered like one rung. So one network, one rung. But here I can do one network, two rungs. Right? Okay, you go back to change back to ladder. Yeah, ladder function block. Yeah. Then you just click here. And this is okay. You add one N. Yeah. Okay. So this is considered one line. This is considered another line, right? Just put any number, same number, then one output. output only different output. Now this one you convert to ladder. Can, right? If you're using S7-300, you cannot do this. S7-300 or 400, one network, only one line. Only 1000 to 1005 is one network, can choose two lines. Any questions? No questions. Okay. What? Yeah, show you the first thing got time. Right. So I show you the analog function. So normally analog I will teach during advanced training. Okay. So we have some time, I can show you the analog functions. Analog functions or okay. But your system don't have any analog functions, right? Analog means very simple. Like I get a value. So actually it's okay, but just now the position, right? It's in mm, right? How you get the value? From the drive, is it? No. Or encoder?
Not sure.
Not sure.
Yeah.
But it's in mm, right? Just now. When it's in, just now in the calculation, you have tried that calculation. Okay? Okay, never mind. I'm sure I think it must be analog or encoder. So analog means, okay, so far we use digital, right? Like a push button, selector switch, okay, the output like most of the signal, right? So your system will have so many sensors, right? The lock, what they call the twist lock, all that got sensor, right? Okay, can be feedback, okay. So all that called digital. Mostly your system will using digital. But some of the value you use are maybe it's an encoder or analog signal. I'm not sure because must have a motor to rotate, right? So the VFD is controlled by your PLC. Okay, correct. So the speed, who control the speed? Speed it can like example, let's say the crane go down and up, right? Okay, it's who control the up and down? The S7-1200.
Up and down.
No,
Yes.
this PLC like PLC controlling the up and down, right? The spreader is controlled by the impact,
Yeah.
right? Okay, but the crane up and down is this PLC. Okay, then okay, never mind. The spreader is move 40 feet, 20 and 25, right? Is it controlled by a motor?
Yes.
Right. Okay. Can the motor speed can be increased or the speed is fixed?
I think it's fixed.
Fixed speed.
Yeah.
There's no speed difference. Lah.
Yeah.
Okay, okay. So because PLC can control the speed also. So it means the speed of the motor is fixed. So PLC only send a command lah
Yeah.
to move, to rotate clockwise and rotate counterclockwise. Right. So that one will be your what they call like a digital inputs. Okay, that's a digital inputs. But how I know whether it's at 40, 45 or 20? Is it a sensor?
Yes.
Okay, so means every position they have a sensor. Okay, so for example, okay, I wanted to from 20 I wanted to move 40. So let's say I rotate clockwise, for example, right? So I rotate clockwise. So from 20, okay, move. Once you reach the 40 sensor, cut off the motor. That's how we go. Okay. So I think don't have an analog. Okay, never mind. This is just additional knowledge. Okay. So analog means very simple. Okay, which is range. Okay, range. Because digital is just on or off. Analog means you have a range. So in industry, we have two types of range. One is voltage, one is the ampere voltage, 0 to 10 volt, negative 10 to positive 10 volt, 2 to 10 volt, and so on. So common one is this. Then ampere you have 0 to 20 milliamp or 4 to 20 milliamp. These two. Okay, common one is this. This is analog. Okay. So what are the analog inputs? So you see like analog input. Like the temperature, you can measure the temperature, okay, the pressure, okay, then you can measure the humidity, okay, you can measure the VFD speed, okay, you can measure the VFD speed, you know VFD, right? Drive, huh? So VFD speed, what else? The gas percentage, okay, any gas lah, depend on the sensor. So you want to measure carbon dioxide, you want to measure what gas? Methane gas, because of lithium one I'm using two. One is the carbon dioxide, one is the methane gas. You measure, okay? Also many nitrogen, all that you measure also. Okay, so we then what else? What else we measure? Flow, distance, distance, you can say distance or like a level. Like a time means you have a level switch, right? So all these are because you have a range, okay? And analog outputs, normally you control the VFD speed. This one is speed feedback actually. This one is a VFD set speed. You can set speed. Okay. Then, but actually, if you see all VFD only, so you can control pump. Okay, pump also is considered a VFD, right? Because a drive only going to control a pump. Pump is like a motor, right? Only the drive. The same drive is controlling your VFD also. So it's the same thing only actually. Okay. Then a pump, the valve. Because some valve, because this valve is not like, it's like a open percentage. Because some valve open close. Just like a project we did, right? It's like a open close. Some valve you can open a percentage, 10%, 20%. So if you ask me an analog output, any signal that has to do with the rotation, if you ask me now. Anything to do with the rotation. If I can control using the rotation, then it can use these values, then this is an analog. So for example, let's say I have an actuator. Okay, actuator like a cylinder lah, right? Okay, like a cylinder, but cylinder just open close, right? So sometimes actuator with the value means you can just, of course we have a motor, correct? Motor rotate, then extend, then retract, right? So let's say I put one for the door, for example. So I can choose, okay, how many percent I want to open. Is it 50%? Then the motor rotate. But we need to do the values and everything, okay? So if you ask me, analog output mostly anything with the rotation line. That's the easiest way, okay, to understand. Okay, can I get this? Now we see how the analog works. See, we have for the analog input. Okay, so we have a CPU, right? The PLC, yeah. Then I connect the analog input module. Okay, or even our digital also same. It's a CPU. Then we connect a digital input module, right? Okay. Then we connect a 24 volt or 0 volt signal to the digital input. So what the digital input card will do, will convert this signal into 0 or 1. Right? That is the function of my digital input. The same concept for analog input. Okay. So analog input will get the data. Data from where? Transmitter. So they call transmitter or transducer. Okay, transmitter or transducer. So this transmitter transducer connect to where? Connected to your measurement device. Measurement device means your like a temperature is like a temperature probe. If pressure means it's a pressure transmitter. Flow means it's a flow transmitter. Okay. Now this, so let's say this is a temperature sensor. So this temperature sensor measures 0 to 150 degrees Celsius, for example. Okay. So it sends a signal to the transmitter. Transmitter will convert this value into the analog value, which is 0 to 10 volt or 4 to 20 milliamp. Right? Because these are the analog signals. Now my function of analog input is convert this value into digital value, which is 0227648 for Siemens. Different PLC, different style. Okay. That is the function. So what I need to do now as a programmer, actual temperature is 150, right? After using the transmitter, let's say it's convert this data into milliamp current. In the PLC, I get this. Now, the programmer need to convert this to this is where you do the calculation and everything. Okay, just now we do just now we see your system also got some calculation. But the only thing is, I'm not sure how they measure. So 100% sure they're using encoder. Encoder means so what they do, they will fix with the rotator, something rotating lah, right? So when it's moved, it will give the value. So what they do, of course lah, it won't give you in mm. That's why they do calculation. They give you in some value. Then you need to know. Okay, let's say according to the encoder, let's say 25 rotation is equal to 1 cm, for example. Or cannot be that because the encoder is because it depends on what type of encoder you use. So it's in milliamp. So I mean mm. So normally it will be like, for example, one complete rotation. Let's say you got 100. Consider is 100 lah. So means it is already moved 10 milliamp millimeter. So you need to do conversion, do the calculation. Same thing here also, same concept. Okay? So what I need to do? I need to do a plot a graph, analog input, convert to temperature. So my analog input, what is the value? This is the value, right? 02768 convert to 0 to 150. Now what we need to do? We can use y equal to mx plus c, our linear equation, right? Okay, but you can use your own calculation lah, right? Find out the m. M is what? Y divided x. Then x is your analog input. C is 0 or nothing, right? So once you find the m, multiply with your analog input value, then you get the y. But Siemens, they already, all the PLC they already have. But what is this? I'm not sure they have the scaling block. But normally other PLC they already should have one. They have the scaling block. So you just use the scaling block. Just do the scaling. So they ask you to put what is the minimum input, maximum input, minimum output, maximum output. What is your input? What is your output? Just key in all the data. It can calculate. So that is for analog input. Analog output, the same thing. CPU, analog output, connect to a VFD, this one connect to a motor, right? Okay. So now the thing is, now here I receive this value, right? I receive in milliamp, then my card will convert to this value. That means I receive this value, I convert back to this value. Now here is the CPU need to give this value to my analog, like an output. Like an output, what we do actually? You put a coil, then you put the output. Means you set you send value 1 into your output. Right? It's like you are moving the value 1 into your output. So that is what. So the same numbers. So So you put this value to your analog. Of course this one need to add the address okay. Then this one go here 0 to 10 volt, 4 to 20 VTM. Then this one can go to here. Of course your VFD can control the motor. Now it depends whether you want to control it 0 to 50 Hz or 0 to 1500 RPM for example lah. So for this also you need to do calculation. Why I need to do calculation? Because now here we need a set point. Right, how much? 0 to 50 for example. Then need to convert to analog output value 0 to 27648. So now this one becomes X axis. This one becomes Y because you know in this calculation X is the one we key in. Right. This is the result. So if you want the motor run 50 Hz, so in the HMI you key in 50. So the HMI data is this. You do the calculation, you convert into this, send out to your analog output. So the function of your analog output, the module, convert this value into this value, go to your drive, and the drive can control your motor. Okay, this is analog functions. Because I think maybe you cannot imagine, right? Because you haven't used before, right? So you cannot. How to say? Because I think your system will have a lot. Because you only do that particular thing, right? You don't do any other functions. I mean, any other machines, no. You only do that one. Because that one you don't have. But mostly it's a motor. Mostly you controlling the motors, right? But the motor speed also is a constant speed. Then I think the position you get must be an encoder. Encoder is like this. Have you seen before? Encoder, this is the motor, right? This is the motor. This is the drive. Like this. So normally what happens, one can see this encoder, this one. They give me the resolution. Okay, but this one using the Profinet communication now. No, you can actually use this also. Using this. Some encoder they have what straight away some cables like input signal. So what happens inside here? You have like a disc, you know. Then they will have a laser. So let's say here the laser. So when rotate in the disc, right, they will have like a small holes. So like just rotate one, it can count one. Then just little bit rotate, can count. So like one rotation will have like it's depend on the encoder lah. But this encoder didn't put it here because I was checking the manual. sometimes they put like one complete rotation like rotation per minute, so it means like 1000 RPM means one rotation can give you number 1000. So what they do, this is the one rotating, right? Of course they will have some gear to move everything, right? At the same time this one they will attach here. So when this one is moving, this one also move, right? So what happened, from here they can get the feedback. What is the current position? Because just now I see your current position is a value, right? Okay. Of course you have a sensor to stop, but of course the sensor what is for 20, 40, 45 you have a sensor to stop, right? But if you from 20 to 40 you will have the value will change, right? From 20, 21 feet, 22, 23 until 40 feet. You can see the value, right? No.
Yes, I think no.
No. You can see the value. Then what is the current position value just now?
Current position value is for the twin unit only.
Twin unit.
Can retract and extend.
Okay.
We only can see the twin.
Okay, what value you will see then? In mm.
Yeah.
So every mm we can show?
Yeah.
Then it will be shown. Then they use angular. So what happens is they just connect to this. So of course this one here will control your movement lah. Then this one rotate. So what they do? Okay, they know. Okay, what they do? They will calculate. Okay, they will open the motor like until the end one. Okay, so they will count here. Let's say 40 feet. Actually same thing like that. So let's say it's 0 to 40 feet. But what is the value I get here? Let's say 100,000. So I do the conversion. So it means then I can, so from there I can know already. So one complete rotation is, let's say 1,000. So it means 100,000. So I rotate 100 rotation. So 100 rotation is equal to 40 feet. Then I can count. That's where we use the max function. Oh, this scaling function is okay. So if you want to get a value, so let's, this is for the encoder. So this is the encoder value. So what is the encoder value? For example, from here to there, right? Let's say 40 feet. What is the encoder value? Let's say 0 to 80,000. For example, okay, is equal to what? This one is in mm example, huh? So 40 feet to mm how much? Uh, 12,192. So 12,192. Okay. Because encoder will give you correct value, accurate value. So once you do the calculation, same thing as this calculation. So once you do the calculation, so when the encoder slowly increasing, we can know already what is the distance. Because in the wiring diagram is impact wiring diagram, right? The diagram.
Yeah.
Is which wiring diagram for which one? For the S7-1200 or for the impact one? You open. Let's see, got any encoder? This is emergency stop, is it?
Yeah.
This stop switch you're going to pills. Okay, next. Spare. Okay, this is the can. Okay, next. Next. Internet connection. Okay, next. Next. Telescoping outflow. Okay. Okay, maximum oil pressure. Please level low. Please level pressure. Okay, next. Spare. Okay, next. Okay, next. Separator position 40 feet, 45 feet. Go. Okay. Next. Next. Rolling. Next. Next. LED signal. What do you see? Signal impulse. Showing all. Next. Next. PC type. Norming. Next. Next. Heart indication system. Next. Counter position. Next. That's all, is it? Not using. And this one is what? 25 volt, 25 watt. Oh, I think this is. You go here, you click on this one. Can heating. Okay. Motor heating. Oh. It's a motor heating. Thing is like a thermostat. Think if a motor overheat, it will cut heating supply. Oh, it's a heater. Is it a heater? P16. You think this one? P16 is what? Can I copy it? Yeah, okay. Plastic heater. Oh, it's a heater. Need to heat something. Need to heat something. Oh, oh.
But I'm not sure what is the function of the heater.
Yeah. It's a sea heater, yeah, right. So, but it's not very big, like it's a 30 watt. Okay. Like a normal our lamp, lamp. Maybe just to reach to certain temperature, like for the motor to run, motor to heat. Okay. I think yours also don't have the encoder. How they get currency? Parts list. You go up. Go up. Go up. Okay, go to next. Next page. Okay, wait ah. New system, backside panel. Okay, okay. Okay, next. Next. Now go back. Backup alarm. Next. This is the module, is it?
Yeah.
We call ECU lah. 听下榴莲，这个all yours is all using digital inputs, DIDO. Because for all they have, the signal ready, right? So if low pressure, low temperature, right? Oil temperature, oil level low, right? Oil pressure okay, if not okay, then we get a signal, all the signals. The release system level low means for everything they have a sensor, high low sensor. Okay. Alright, any question? If no question, we can end the session. Because the advanced level, yes, we can learn this analog or
I
that.
think the analog, I set the analog for frequency drive, frequency color. Got set this color before, and then the effect, right? There is some I/O, have the AI,
Okay, okay, okay.
and I just remember they can show in this,
Where?
this right. So this I/O can be house,
Yes,
DIDO,
it can be
some,
pulse or DIDO.
but some can use in AI.
Here.
This one.
Yes, it can be AI or ADI, right?
Yeah.
Yeah, but what I'm not sure, you go up, it's a what signal? It's a this is stop, so it's a DI already.
Yeah.
Ah,
But for one project, also my computer got not. I think
feedback. So that is, it will be like this one. So it's current, but I'm not sure. They just put current on it, right? They didn't put 4 to 20 milliamp or 0 to 20 milliamp. And also we don't not very sure how it works. Okay, maybe you
This
click,
one,
click on the frequency. This one. You click on this one. Output frequency drive. Okay, analog. Okay, yes. So they connected to analog common. Then they using this. Yes. So from the drive. So from the drive. Okay.
this time I calculate the value one by one.
You calculate.
My senior teach me how to calculate. So
Okay.
we take a estimate value to do the calculation.
Okay.
So I not very remember, but when I record the value right, so I use the motor input output and I use the multimeter to
Okay. You measure what? You measure the speed or you measure the current?
I think it's current also got
You measure the current.
current and speed.
Okay. Now the thing is, normally if you're using a drive,
Yeah.
the drive will have like this. I'll show you.
Check that the calculation is.
You see this drive. Normally this drive, right, have a feedback. You can see here AI to AO, right? So AO means from here output, then from go to the PLC lah. So normally the AI AO normally will be the frequency only. It won't give the current. What is the current consumption of this? Unless you're using communication to take the value. Communication means like example like you're using the CAN communication or something like that. So you're using communication to get the value, then you can get the motor speed, the motor amp, the motor voltage, everything you can take. But if you're doing like this, like in the wiring diagram, I see it's look like taking the data from the terminal to like this, right? It means only the feedback only. The speed.
During I record my data, the spreader must be moving.
Okay.
And then try to find.
So the calculation you do in the HMI.
Yeah.
Okay. Hmm. 208.11, then you make it the frequency current.
Yeah, but how I get the 20.11 I also know.
Okay, that one I know very very good. Okay, but why what? Okay, so divide to something. This one is, but what is the range here?
Range.
Ah,
I
do you know what will be the range?
no.
You don't know, huh? So actually, what is the value? Can I erase this?
Yes.
So I know what is the constant, but I'm not sure the range lah. What is the range? Okay. Let's assume 50. Because we don't know what is the range, right? Okay, but I know what is the value here. Why they do this? Okay. Now, is okay. So now your idea very simple. You want to convert the AI value, like this AI value is the frequency current, right? Can you see? To real. So you convert this integer, like just now we do in the Siemens we do, right? Integer to real, then I divide. Because this always my analog always is an integer, cannot be real. So I convert to real, then I divide 208.11. Okay, what is 208.11? Very simple. I think this is what your senior do. Okay, this one is the frequency, right? Because the thing is, this meaning, right? That's why English lah, right? This current can be the current frequency or the current ampere. So that's why I don't know. Okay. Okay. So I don't have the idea. So normally it be the speed, correct or not? Okay. The speed you go up. Go up. I want to see this line. What is this line?
What is the fight in the world?
Oh, so this 2 byte going to this word lah. Okay. Okay, they got it. Okay, now. So we don't know what is the values. Let's assume this is some number 0 to let's say use the Siemens format for example. Let's say 0 to 27648. Okay. Then I want to convert this number into 0 to 50. Okay, I want to convert this to this, right? Now, 27 divided 50, I get how much? 27 648 divide 5.2 something. Okay. Then no, don't put 27. We put around 10,000. So 10,000 divide how much? 10,000 divide 50. I get 200. So means every 200 is equal to 1 per hour. That's the logic lah, right? So now what they do here is divide, we put 200. This is the output, this is the two real. So this is your analog value, this is the frequency. So it means if I get 10,000 divide 200, I will get how much? 50. Correct. So here I get the 50. So that's how your engineer get 208. So very simple. To know what is the value, if let's assume the frequency is 50, right? So if you multiply the 208 level, 50 multiply 208, how much? 10,450. So 10,450. So if you divide this, you will get around this number. I assume lah. So that's why. Means he manually do. He didn't do a calculation for this. He manually calculate and do here. But what I like to do is I like to do the calculation inside here. You know why? Because now the 208 is because of this. Let's say in the future, after some time, this value can change to 40. Correct. So 40 means what I get? So if 10 for 40, so I won't get 208.11, I get 208.8. A different number. So I need to go and change it. Every time I need to calculate. If I do my own calculation, scaling, that is, I do it this way. Input, output, in, max, in, out, max, out, min. I do something like this. My own block. Inside the block, I do the scaling y equal to mx plus. Scaling is simple. Then input is what? AI. Input max is what? 10440. So anytime I can change here. So it automatically calculate. Input minimum 0. Output max 50. Output minimum 0. Then here is the frequency. So the 208.11 I don't need to calculate. It will calculate inside. So but this is a function block, right? So inside there, of course, I need to do the scaling. Or this one, I don't know whether you can watch scaling or not. You go to Mac operators. Addition. Okay. Go to other operators. SCL move. Okay. Go to function blocks. Any other function block? Don't have. Because this is not IEC standard. This is our own calculations. Okay, good. Questions? Anything you want to ask? Okay. If you're not very sure, then you can give my number, right? Because I mean, you take picture and send it to me. I want to know what is the that. Okay. Then you can get the data from the help also, right? The thing is, the most important, you need to understand whether it is a Boolean The most important thing actually that is the one meaning. Is it a boolean or integer, double integer, real, word, double word, kind. That is it. Once we know that, then okay. Okay, good. No question. I think we can. Whatever you learn, you copy from here.
I can get the E18
Install IF in my cloud. So if you give me your email address, so I can share that cloud. Or do you have a pen drive?
Yeah.
How big is the pen drive?
How big I am not sure. Because it's long time I not use it.
Is it more than 32 GB?
I don't know.
Okay. Because the software is very small only, but the space are very big. PLC software, PIA version 18. Version 18 only, 7 GB.
Already check first.
Mm-hmm.
So,
Or I can put in my Google Drive, then I can send the link, you can download from there.
if the pen drive got 20 gig is
Space,
enough.
ah?
Yeah.
Yeah.
Thank you.
Okay, my name is Aisha.
Okay.
So later you email me, give me your email address. I will send you the drive link, so you can download from the drive.
I'll give you my email through WhatsApp.
Okay. Prepare for tomorrow. Tomorrow I have another one.
Thank you very much.
Okay, see you. Have you already taken the certificate?
Yeah.
Did you receive the email for digital copy certificate?
Finish it. Oh.
Spoiling.
Oh, sorry. அந்த டேப் மாட்டிக்கிச்சு. அதான் இந்த pictures.
Just the responded to inside the box. Yeah, but removes the amount. Just whichever we already just.
Where's the pink box?
Pink box. I don't know.
அது இருக்குல்ல
Yeah, just over there. Yeah. Huh? 11.
I think we only have one, right?
Yeah, we only have the small one. Okay, thank you so much. I'm going to end this session now. Tomorrow will be Panasonic PLC for the first time. So yeah, I haven't prepared the manual yet. So if you guys looking for PLC training, just inquire with us. So alright, thank you guys. Thank you for supporting. Thank you for subscribing. Take care. Have a nice day. Bye.